The ocean is as mysterious as it is endless. In our continuing exploration of the world's most dangerous maritime enigmas, we dive deeper into the unknown, venturing where few have gone before and fewer have returned. From massive undersea waterfalls that dwarf Niagara Falls, to glowing waves that transform the night sea into an otherworldly light show, to ghost ships found adrift with meals still warm on the table, to submarines that vanished without a trace during the Cold War's silent battles, these are the ocean's most haunting puzzles. In part 2 of our journey into the deep, we'll navigate through phenomena that challenge our understanding of physics, biology, and sometimes human nature itself. These aren't legends or myths, they're real mysteries that continue to baffle scientists, haunt survivors, and capture our collective imagination. So settle in and join me as we continue our descent into the unknown. The deeper we go, the stranger it gets. Welcome to Inside the Most Dangerous Ocean Mysteries, Part 2. Story 18, Undersea Waterfalls, the ocean's hidden cascades. From the bizarre creatures surviving in Antarctica's frozen depths, we now turn to one of the ocean's most spectacular yet invisible features, undersea waterfalls. While we typically think of waterfalls as dramatic plunges over cliffs, the world's largest cascades actually exist entirely underwater, hidden from human sight. These submarine cataracts dwarf anything found on land, with heights exceeding 11,500 feet and water volumes hundreds of times greater than Angel Falls or Victoria Falls. From the Denmark Strait Cataract between Greenland and Iceland to the massive Congo Canyon waterfall off Africa's west coast, these hidden giants shape ocean currents, influence global climate, and create unique ecosystems in the darkness of the deep sea. Let's dive into the remarkable world of undersea waterfalls, where the ocean itself seems to pour into the abyss. The concept of a waterfall existing entirely underwater might seem contradictory at first glance. After all, isn't water already, well, underwater? But the ocean isn't a uniform body of liquid. It's stratified into layers with different temperatures, salinities, and densities that don't readily mix. When these different water masses meet at underwater cliffs or continental slopes, the denser water can literally cascade down like a waterfall, creating massive submarine cataracts invisible from the surface. The largest of these hidden giants is the Denmark Strait Cataract, located in the narrow channel between Greenland and Iceland. Here, cold, dense water from the Arctic meets warmer Atlantic water, creating a temperature differential that drives what is essentially a continuous underwater waterfall. The numbers are staggering. This invisible cascade plunges 11,500 feet, more than 3 times the height of Angel Falls, the tallest waterfall on land, and carries nearly 5 million cubic meters of water per second, equivalent to almost 2,000 Niagara Falls combined. This immense flow occurs because water from the Arctic is not only cold, but also relatively salty, making it significantly denser than the surrounding Atlantic water. As this dense water mass reaches the edge of the Greenland-Iceland ridge, it spills over in a continuous cascade, forming a density waterfall that has flowed uninterrupted for thousands of years. Unlike terrestrial waterfalls, which are driven primarily by gravity acting on elevation differences, undersea waterfalls are powered by the complex interplay of temperature, salinity, and resulting density variations. This makes them more akin to avalanches than traditional waterfalls, massive volumes of denser fluid flowing through lighter surroundings. Another spectacular submarine waterfall is found in the Mediterranean, where dense, highly saline water pours over the Strait of Gibraltar's underwater ridge into the Atlantic Ocean. This underwater cascade, known as the Mediterranean outflow water, creates a distinct layer that can be traced thousands of miles westward into the Atlantic. The salty water flowing over this submarine cliff eventually contributes to the formation of North Atlantic deep water, one of the primary drivers of the global oceanic conveyor belt that regulates Earth's climate. Perhaps the most dramatic undersea waterfalls form in submarine canyons, massive underwater ravines carved into continental shelves. The Congo Canyon, extending from the mouth of the Congo River into the Atlantic, features an underwater waterfall that begins 1,000 feet below the surface and plunges into the abyssal plain. During peak flow periods, sediment-laden water rushes down this channel at speeds approaching 20 miles per hour, scouring the canyon walls and carrying enormous volumes of material into the deep ocean. Similarly, the Monterey Canyon off California's coast hosts a series of spectacular submarine cascades that activate during winter storms and seismic events. These episodic underwater avalanches can transport millions of tons of sediment in a single event, reshaping the canyon floor and dramatically altering local topography. What makes undersea waterfalls particularly fascinating to oceanographers is their outsized role in global ocean circulation. These dense water cascades are key components of the thermohaline circulation, the global network of deep ocean currents driven by differences in temperature and salinity. As cold, dense water sinks at high latitudes and flows toward the equator, it creates a circulatory system that distributes heat, oxygen, and nutrients throughout the world's oceans. This circulation has profound implications for Earth's climate. The Atlantic meridional overturning circulation, which includes the Denmark Strait Cataract, helps moderate temperatures in Western Europe by transporting warm tropical water northward. Any significant disruption to this underwater waterfall could potentially alter climate patterns across the Northern Hemisphere, highlighting the hidden yet crucial role these submarine features play in our planet's temperature regulation. For maritime operations, undersea waterfalls create unique challenges and hazards. Submarines navigating near these features must contend with powerful and unpredictable currents that can affect maneuverability and create acoustic anomalies that complicate sonar operation. Similarly, deep-sea submersibles and remotely operated vehicles working near submarine canyons risk being caught in sediment flows or turbidity currents, essentially underwater avalanches that can damage equipment and endanger operations. Underwater communications infrastructure is particularly vulnerable to these hidden cataracts. Submarine telecommunications cables, which carry over 95% of international data traffic, must be carefully routed to avoid areas where underwater density flows might damage them. Despite these precautions, cable breaks attributed to submarine avalanches and turbidity currents occur regularly, disrupting global communications and requiring costly repairs using specialized deep-sea vessels. Beyond their physical and operational impacts, undersea waterfalls create unique ecological niches that support specialized biological communities. The turbulence generated by these flows enhances mixing of nutrients and oxygen, creating productivity hotspots in otherwise nutrient-poor deep ocean environments. Around submarine canyons with active density flows, researchers have documented unusually high biodiversity, with dense aggregations of filter-feeding organisms positioned to capture food particles carried by the underwater cascades. Some of the most spectacular biological communities associated with undersea waterfalls are found where Mediterranean outflow water cascades into the Atlantic through the Strait of Gibraltar. Here, the interaction between different water masses creates complex current patterns that concentrate nutrients, supporting rich assemblages of corals, sponges, and fish that thrive in the enhanced food supply created by the submarine cataract. These biological communities aren't just scientifically fascinating, they also hold enormous potential for bioprospecting, the search for novel compounds with pharmaceutical or industrial applications. The unique evolutionary pressures exerted by submarine waterfall environments have potentially driven the development of specialized biochemical adaptations that could be harnessed for human benefit. What makes undersea waterfalls particularly compelling from a scientific perspective is how recently we've begun to understand them. While terrestrial waterfalls have been documented, measured, and studied for centuries, their submarine counterparts remained largely theoretical until the late 20th century. Only with the development of advanced sonar systems, autonomous underwater vehicles, and sophisticated ocean modeling could oceanographers begin to comprehend the true scale and significance of these hidden features. This understanding continues to evolve as new technologies enable increasingly detailed observations. High-resolution mapping using multibeam sonar has revealed the complex topography of submarine canyons and the scarring patterns created by density cascades. Neutrally buoyant floats equipped with sensors provide data on flow rates and trajectories. Environmental DNA sampling offers insights into the biological communities associated with these features without the need for direct observation. Despite these advances, much about undersea waterfalls remains mysterious. Their episodic nature, particularly in submarine canyons, makes them difficult to study directly. The extreme depths at which many occur limit direct observation opportunities, and their complex three-dimensional structure challenges our ability to model and predict their behavior accurately. Climate change adds another layer of uncertainty to our understanding of these features. As Arctic ice melts and freshwater input increases at high latitudes, the density differentials that drive major submarine waterfalls, like the Denmark Strait Cataract, may weaken. Conversely, changing precipitation patterns and coastal erosion could increase sediment delivery to submarine canyons, potentially intensifying turbidity, current activity. These changes could have far-reaching consequences for ocean circulation, nutrient distribution, and marine ecosystems globally. For all their importance and grandeur, underwater waterfalls remain largely invisible to human experience. Unlike their terrestrial counterparts, which draw millions of tourists annually with their visible drama and thunderous sound, submarine cataracts operate in silent darkness, their massive scale appreciable only through scientific instrumentation and computer visualization. This invisibility heightens their mystique while complicating public appreciation of their significance. How do you convey the awesome power of a feature that no human can directly observe in its entirety? How do you build conservation awareness for processes that operate far beyond human sensory perception? The answer may lie in the growing field of scientific visualization, which transforms complex oceanographic data into compelling visual representations. Modern animation techniques can now render the Denmark Strait Cataract or Congo Canyon Cascades with striking realism, translating invisible submarine processes into experiences that resonate with human visual perception. These visualizations not only advance scientific understanding, but also build public appreciation for the ocean's hidden wonders. As our technology and understanding continue to advance, underwater waterfalls stand as powerful reminders of how much remains to be discovered in Earth's oceans. These massive features have shaped marine environments for millions of years, operating according to physical principles we've only recently begun to comprehend. Their exploration represents not just a scientific frontier, but an opportunity to expand our conception of what constitutes a waterfall, challenging us to look beyond the visible world to the powerful forces operating in the ocean depths. The next time you stand before a majestic terrestrial waterfall, marveling at its power and beauty, remember that far beneath the ocean's surface flow even more spectacular cascades, cold, dense rivers within the sea itself, pouring ceaselessly into the abyss, invisible giants shaping our blue planet in ways we're only beginning to understand. Don't let our exploration of these hidden marvels cascade away without subscribing. Like these powerful undersea currents, your support creates a flow that helps our channel reach new depths of discovery. Click that subscribe button now with your pipeline to more fascinating ocean phenomena that most never see. Each subscription helps us dive deeper into these mysteries, ensuring you'll never miss our next underwater adventure. Now, let's surface to examine one of history's most mysterious submarine disappearances. Story 19, USS Scorpion Submarine, Cold War Mystery in the Deep. From the hidden waterfalls flowing beneath the waves, we now surface to examine one of the Cold War's most enduring maritime mysteries, the fate of the USS Scorpion. On May 22, 1968, this nuclear-powered attack submarine disappeared in the Atlantic Ocean with 99 crewmen aboard. Unlike many lost vessels whose locations remain unknown, the wreckage of the Scorpion was eventually found, but the exact cause of her sinking continues to baffle experts more than 5 decades later. Was it a mechanical failure, an accidental torpedo detonation, or something more sinister involving Soviet forces? As classified documents slowly become available, and new analysis techniques are applied to old evidence, the story of the Scorpion continues to evolve, revealing a complex web of technical failures, operational pressures, and geopolitical tensions that culminated in tragedy nearly 10,000 feet beneath the Atlantic. The USS Scorpion, designation SSN 589, was a skipjack-class nuclear submarine commissioned in 1960, representing the cutting edge of American undersea technology during the height of the Cold War. With a top speed exceeding 30 knots submerged and armed with advanced torpedoes, she was designed to hunt and, if necessary, destroy Soviet submarines in the event of open conflict. Like all nuclear submarines of her era, the Scorpion operated largely in secrecy, her movements and missions known only to a select few within the Navy's chain of command. In February 1968, the Scorpion departed Norfolk, Virginia, for a 3-month deployment to the Mediterranean Sea. Her mission involved monitoring Soviet naval activities in the region during a period of heightened east-west tensions. After completing this assignment, she headed back toward her home port in late May, expected to arrive on May 27th. On May 21st, the Scorpion sent her last routine message, reporting her position about 400 miles southwest of the Azores. After that transmission, silence. When the submarine failed to arrive in port as scheduled, the Navy initiated what would become one of the largest search operations since the disappearance of Amelia Earhart, involving dozens of ships and aircraft scouring thousands of square miles of ocean. The search initially yielded nothing, but the Navy had an ace up its sleeve, a top-secret underwater surveillance system called SOSUS, that's Sound Surveillance System, designed to track Soviet submarines across the Atlantic. Analysis of SOSUS data revealed an unusual acoustic event near the Scorpion's last reported position. This crucial intelligence narrowed the search area significantly. In October 1968, 5 months after her disappearance, the deep submergence research vessel Mizar located the wreckage of the Scorpion. Photographs revealed the submarine resting on the ocean floor at a depth of approximately 11,000 feet, broken into 2 major sections with debris scattered over a wide area. All 99 men aboard had perished in what remains one of the worst submarine disasters in U.S. Navy history. Finding the wreckage, however, only deepened the mystery. Unlike the situation with many shipwrecks, where physical evidence clearly indicates the cause collision damage, explosion patterns, or flooding evidence, the Scorpion's remains presented a confusing tableau that experts continue to debate to this day. The Navy's initial investigation, conducted from 1968 to 1969, concluded that the most likely cause was a malfunction in one of the submarine's own torpedoes. According to this theory, a battery failure in a Mark 37 torpedo caused it to activate inside its tube, leading the weapon to begin running hot. The crew, recognizing the danger, may have attempted to eject the torpedo, but it either detonated or caused a catastrophic fire that ultimately led to the loss of the vessel. This explanation was plausible but problematic. The physical evidence from the wreckage wasn't entirely consistent with a large internal explosion, and subsequent examination of similar torpedoes failed to demonstrate how such a battery failure would lead to detonation rather than simply rendering the weapon inoperable. As the initial investigation closed, other theories began to emerge. Some focused on the Scorpion's mechanical condition. The submarine had a history of mechanical issues, including problems with her hydraulic systems that controlled the critical stern planes, the control surfaces that determine a submarine's depth. A failure in these systems could potentially have caused an uncontrolled dive beyond the submarine's collapse depth, where the hull would implode from external pressure. Supporting this theory was testimony from crew members who had previously served aboard Scorpion, describing ongoing maintenance problems and the submarine's rushed deployment schedule, which limited opportunities for thorough repairs. The Scorpion had been due for a major overhaul upon her return to port, an overhaul she never received. Another compelling theory involved the trash disposal unit, a system used to eject waste from the submarine while submerged. If the internal valve of this system failed to close properly after use, it could have allowed seawater to flood the submarine, potentially triggering a catastrophic chain of events leading to an uncontrolled descent and hull collapse. But perhaps the most controversial theories surrounding the Scorpion's loss involve potential Soviet involvement. The late 1960s marked a period of aggressive underwater surveillance and counter-surveillance between American and Soviet naval forces. Some former Navy officers and historians have suggested that the Scorpion might have been trailing a Soviet naval group when something went catastrophically wrong. One version of this theory proposes that the Soviets detected the American submarine and attacked it, either with depth charges or torpedoes. Another suggests that the Scorpion might have been accidentally struck by a Soviet submarine during an underwater surveillance operation gone wrong. These theories gained traction in the 1980s and 1990s as information emerged about how close Soviet and American submarines operated to each other during Cold War cat-and-mouse operations. Fuel for these theories came from Dr. Fowlis. John Craven, the chief scientist of the Navy's Special Projects Office, who later wrote that analysis of acoustic data suggested the Scorpion had been attempting evasive maneuvers shortly before her loss. Additionally, declassified documents revealed that the Soviet Navy had conducted an unusually extensive search in the Atlantic around the time of the Scorpion's disappearance, possibly indicating they knew something had happened. However, as more Cold War archives have been declassified, evidence for direct Soviet involvement has failed to materialize. Most naval historians and submarine experts now discount the Soviet attack theory, noting that had such an incident occurred, it likely would have emerged during the post-Cold War opening of Soviet military archives. In the 1990s, a new investigation led by submarine designer Bruce Rule brought advanced acoustic analysis to the Scorpion mystery. Rule analyzed the SOSUS recordings with technology unavailable to the original investigators and concluded that the submarine had suffered a catastrophic implosion as it exceeded its crush depth. Crucially, Rule's analysis identified no evidence of a torpedo explosion prior to the implosion event. This finding shifted focus back to mechanical failure theories. The most comprehensive explanation, now widely accepted by many submarine experts, suggests a cascading series of failures, possibly beginning with an electrical problem that led to loss of power, followed by an inability to maintain depth control, resulting in an uncontrollable dive that exceeded the hull's crush depth, causing the catastrophic implosion detected by SOSUS. The Navy's reluctance to fully declassify all materials related to the Scorpion has fueled ongoing speculation. While many technical documents have been released, others remain sealed, ostensibly to protect sensitive information about submarine vulnerabilities and acoustic detection capabilities. This continued secrecy has allowed alternative theories to persist and evolve over the decades. Beyond the technical debates lies the human tragedy of the Scorpion disaster. The 99 men lost represented fathers, sons, husbands, and brothers whose families have lived with uncertainty for over 5 decades. The Scorpion families have formed a tight-knit community, advocating for continued investigation and full disclosure of all information related to the submarine's final mission. For these families, the technical cause of the disaster is often secondary to questions about whether their loved ones' deaths could have been prevented. Was the Scorpion pushed too hard with inadequate maintenance? Were warning signs of mechanical problems ignored in the rush to maintain Cold War submarine operations? Did Cold War secrecy and operational pressures contribute to decisions that ultimately doomed the vessel? Some answers have emerged through the Navy's submarine safety program, established following the loss of USS Thresher in 1963, but still being implemented when Scorpion was lost. This comprehensive overhaul of submarine design, construction, and maintenance standards has made the modern submarine force significantly safer. No American submarine certified under the completed SubSafe program has ever been lost, a stark contrast to the multiple submarine losses in the decades before its implementation. The Scorpion disaster also transformed how the Navy approaches submarine search and rescue. The techniques developed to locate the Scorpion's wreckage, including the use of acoustic data analysis and deep ocean search technologies, created a foundation for modern deep-sea operations. When the Russian submarine Kursk was lost in the year 2000, these capabilities, evolved over decades since the Scorpion search, enabled much faster location of the wreck, though unfortunately too late to save her crew. In recent years, advanced underwater imaging technologies have been used to revisit the Scorpion wreckage, providing new details about the submarine's final resting place. High-resolution sonar and photographic surveys have mapped the debris field with unprecedented precision, offering new clues to investigators still working to solve the mystery. These new images reveal that the Scorpion's hull shows signs of an implosion that propagated from the operations compartment, the submarine's control center, toward the engine room. This pattern supports theories focusing on control system failures rather than weapons accidents, as an explosion in the torpedo room would have created a different damage pattern. The submarine's nuclear reactor and weapons remain intact on the seafloor, continuously monitored by the Navy for potential environmental concerns. Regular surveys have detected no significant radiation leakage, though the site is considered a potential long-term environmental hazard that will require monitoring for decades to come. For submarine crews serving today, the Scorpion remains a sobering reminder of the inherent dangers of undersea operations. Modern nuclear submarines dive deeper, stay submerged longer, and carry more destructive weapons than the Scorpion ever did, making the lessons of her loss as relevant now as they were in 1968. As technology advances and more Cold War records become available, the full story of the Scorpion may eventually emerge from the depths. Until then, she remains one of the ocean's most haunting modern mysteries, a technological marvel of her time, now a silent monument on the Atlantic seafloor. Her exact fate still whispered about in submarine wardrooms and debated by naval historians worldwide. For the families of the 99 men lost aboard USS Scorpion, the ocean holds more than a mystery. It holds their loved ones, entombed nearly 2 miles beneath the waves in a steel vessel that once represented the pinnacle of American naval technology. Their sacrifice, whether caused by mechanical failure, operational error, or some combination of factors still not fully understood, remains a somber chapter in the history of submarine warfare and deep ocean exploration. While controversy may continue to surround the exact cause of her sinking, what's beyond dispute is the courage of the men who served aboard her, undertaking some of the most dangerous missions of the Cold War beneath the waves and far from home. Their legacy lives on in the improved safety standards, technologies, and procedures developed in the wake of their loss, advancements that have likely saved countless submariners' lives in the decades since the Scorpion transmitted her final message and slipped beneath the Atlantic waves, never to surface again. Now, let's shift our perspective to explore one of the planet's most powerful and destructive underwater phenomena. Story 20. Undersea earthquakes. The ocean floor's violent tremors. From the Cold War mystery of the USS Scorpion, we now turn to a force so powerful, it can reshape the ocean floor in seconds, generate tsunamis that devastate entire coastlines, and create sound waves that travel through both sea and earth with catastrophic energy. Undersea earthquakes are among the planet's most destructive natural phenomena, yet they occur in a realm where humans cannot directly observe them. These submarine seismic events, often far more powerful than their land-based counterparts, create unique hazards for ships, submarines, underwater infrastructure, and coastal communities. From the 2004 Indian Ocean earthquake that triggered tsunamis killing over 230,000 people, to strange seismic events that generate mysterious T-waves detected thousands of miles away, these hidden tremors remind us that the seafloor is anything but stable, and that some of Earth's most violent geological processes unfold in the silent depths where no human can witness them directly. The ocean floor is not the static, unchanging plane that early mariners imagined. Rather, it's a dynamic geological landscape where tectonic plates collide, separate, and grind against each other with tremendous force. When the accumulated stress at these plate boundaries suddenly releases, the result is an undersea earthquake, a violent shifting of the seafloor that can displace billions of tons of water and rock in seconds. What makes submarine earthquakes particularly fascinating from a scientific perspective is their distinctive character. When an earthquake occurs underwater, its energy propagates differently than on land. Seismic waves move through water at different speeds and with different properties than through rock, creating complex patterns of energy transfer that can amplify or dampen the earthquake's effects in unexpected ways. The largest undersea earthquake in recent history struck on December 26, 2004, off the coast of Sumatra, Indonesia, registering a staggering 9.1 to 9.3 on the moment magnitude scale. This massive rupture along the Sunda megathrust involved the movement of a 1,200-kilometer section of seafloor. The Indian plate subducted beneath the Burma plate with such force that it lifted a section of seafloor by several meters, displacing an estimated 30 cubic kilometers of water, enough to fill 12 million Olympic swimming pools. This sudden displacement generated a series of tsunami waves that radiated outward from the epicenter at speeds approaching 500 miles per hour. In the deep ocean, these waves were barely perceptible, rising perhaps a foot or two above normal sea level but extending for miles in length. But as they approached shallower coastal waters, these waves slowed down and grew in height, eventually striking shorelines around the Indian Ocean, with devastating walls of water reaching up to 100 feet high in some locations. The 2004 tsunami highlighted one of the most dangerous aspects of undersea earthquakes, their ability to generate destruction far from the epicenter. While the earthquake itself was centered off Sumatra, the resulting tsunamis killed people in 14 countries across 2 continents. The waves reached the coast of Somalia in Africa, over 4,500 kilometers from the epicenter, still powerful enough to kill 300 people. But tsunamis are just one of the hazards created by undersea seismic activity. For vessels on the surface directly above a powerful submarine earthquake, the experience can be bizarre and terrifying. Sailors have reported feeling as if their ships suddenly hit a reef or solid object, followed by violent shaking and unusual wave patterns that seem to come from all directions at once. Water may appear to boil or churn as seismic energy transfers through the water column, creating turbulence and temporary pressure changes that can affect buoyancy. For submarines operating near the seafloor, the danger is even more acute. A powerful undersea earthquake can create sudden pressure waves, turbidity currents, underwater avalanches of sediment, and even shifts in water density that can affect a submarine's ability to maintain depth control. During the Cold War, both American and Soviet submarines reported harrowing experiences when caught near underwater seismic events, including violent shaking that threw crew members against bulkheads and temporarily disrupted crucial systems. Perhaps the most vulnerable elements to undersea earthquakes are the submarine cables and pipelines that crisscross the ocean floor. These infrastructural lifelines carry over 95% of international data traffic and transport oil and gas worth billions of dollars annually. A single major submarine earthquake can sever multiple cables and pipelines, causing telecommunications outages affecting entire regions and disrupting energy supplies to millions of people. The 2006 Hengchun earthquake near Taiwan damaged 9 submarine communications cables, disrupting internet and phone service across much of East and Southeast Asia for weeks. Repairs required specialized cable ships working around the clock at enormous expense. Similarly, the 2011 Tohoku earthquake off Japan damaged submarine pipelines and communications infrastructure, contributing to the cascade of disasters that included the Fukushima nuclear accident. What makes undersea earthquakes particularly challenging to study is their inaccessibility. Land-based seismic events can be examined directly. Scientists can visit the epicenter, map surface ruptures, and place instruments precisely where needed. Submarine earthquakes, by contrast, occur in an environment where direct observation is extremely difficult and expensive. Researchers must rely on remote sensing, underwater seismometers that may be hundreds of miles from the epicenter, and inferences drawn from secondary effects like tsunamis. This remoteness has historically limited our understanding of undersea earthquake mechanics. However, in recent decades, new technologies have begun to illuminate these hidden seismic processes. Networks of ocean-bottom seismometers now monitor seismically active regions of the seafloor, providing data previously unobtainable. Satellite altimetry can detect subtle changes in sea surface height that indicate undersea plate movements. And fiber optic cables themselves have been repurposed as distributed sensing arrays, detecting seismic signals as they affect the light transmission through the cables. These advances have revealed surprising findings about submarine earthquakes. For instance, scientists have discovered that many undersea fault zones experience slow slip events, gradual movements that release seismic energy over days or weeks rather than in seconds, like typical earthquakes. These slow-motion earthquakes may play a crucial role in relieving stress along subduction zones, potentially reducing the frequency of catastrophic ruptures. Researchers have also identified unique types of seismic waves that only occur in undersea environments. The most fascinating of these are T-waves, tertiary waves, which can travel thousands of miles through the ocean with minimal energy loss. These acoustic waves propagate through the SOFAR channel, a natural underwater sound channel created by temperature and pressure conditions at certain depths. T-waves, generated by even relatively small undersea earthquakes, can be detected by hydrophones across entire ocean basins, making them valuable for monitoring remote seismic activity. The submarine volcano Monowai in the Kermadec Islands north of New Zealand has become a natural laboratory for studying these phenomena. It produces thousands of small earthquakes annually as magma moves beneath its summit. Each quake generates T-waves that travel through the Pacific, creating a unique acoustic signature that allows scientists to monitor the volcano's activity in near real time despite its remote location. Beyond their scientific interest, undersea earthquakes have profound cultural and historical significance. Many coastal cultures have traditional knowledge about tsunami warning signs passed down through generations. Indigenous communities in the Pacific Northwest preserved oral histories describing a massive tsunami that struck the region around 1700, later confirmed by Japanese records and geological evidence to have resulted from a magnitude 9.0 Cascadia subduction zone earthquake. Similarly, ancient Japanese tsunami stones, markers placed by ancestors warning future generations not to build below certain elevations, have proven remarkably accurate in delineating safe zones during modern tsunami events. Some stones dating back over 600 years carry inscriptions like, "Do not build your homes below this point," advice that, when heeded, has saved lives during recent disasters. The relationship between human activities and undersea earthquakes has become an increasingly important research focus. Evidence suggests that certain human interventions may trigger or influence submarine seismic events. Extraction of oil and gas from undersea reservoirs can alter stress patterns in the surrounding rock, potentially triggering earthquakes in areas with pre-existing fault lines. Similarly, injection of wastewater into deep submarine formations, a common practice in offshore oil production, has been linked to increased seismic activity in previously stable regions. Climate change may also influence undersea earthquake patterns through its effect on sea levels. As polar ice melts and oceans rise, the additional water weight places increased pressure on the sea floor. This changing load can alter stress patterns along fault zones, potentially affecting earthquake frequency and magnitude. Some research suggests that seasonal variations in sea level already influence small earthquake patterns in certain regions, raising questions about how longer-term sea level changes might affect global seismicity. For coastal communities worldwide, developing effective warning systems for undersea earthquakes and their resulting tsunamis remains a critical challenge. The 2004 Indian Ocean disaster highlighted the inadequacy of existing systems. The Pacific Tsunami Warning Center detected the earthquake but had no established protocol for alerting countries in the Indian Ocean region. This tragic gap in coverage led to the development of the Indian Ocean Tsunami Warning System, completed in 2006. Modern tsunami warning networks combine seismic sensors, deep ocean pressure recorders, tide gauges, and sophisticated computer models to detect tsunamigenic earthquakes and predict wave arrival times and heights. These systems can provide precious minutes to hours of advance warning, allowing coastal evacuations that save thousands of lives. During the 2011 Tohoku earthquake and tsunami, Japan's advanced warning system triggered automatic alerts on millions of cell phones and shut down critical infrastructure like nuclear plants and high-speed trains before the most destructive waves arrived. Despite these advances, significant gaps in coverage remain, particularly in developing regions with limited resources for installing and maintaining sophisticated detection equipment. The unpredictable nature of undersea earthquakes and the speed at which tsunamis can strike nearby coastlines, sometimes leaving only minutes for evacuation, mean that education and preparation remain as important as technology in mitigating these disasters. For scientists, each major undersea earthquake provides new data that refines our understanding of these complex events. The 2011 Tohoku earthquake challenged existing models by releasing approximately 2 to 4 times more energy than predicted for that segment of the Japan Trench. This unexpected power stemmed partly from the fault slipping almost completely, allowing the plates to move up to 50 meters relative to each other, far more than previously thought possible in a single event. Similarly, the 2012 Indian Ocean earthquakes, 2 massive strike-slip events that released energy equivalent to a magnitude 8.7 quake, revealed that oceanic transform faults can produce much larger earthquakes than previously believed. The complex rupture pattern involved at least 4 different fault planes activating in sequence, creating one of the largest strike-slip earthquakes ever recorded, and generating detectable seismic waves that circled the planet multiple times. These discoveries highlight how much remains to be learned about undersea seismic processes. The ocean floor, constituting over 70% of Earth's seismically active regions, remains largely unmapped at high resolution. Vast sections of submarine fault zones have never been directly studied, and many underwater volcanoes with potential for generating tsunamigenic earthquakes remain unmonitored. As technology advances, our ability to detect, study, and potentially predict undersea earthquakes continues to improve. Networks of underwater sensors grow more sophisticated and extensive each year. Satellite systems provide increasingly detailed views of seafloor movements, and artificial intelligence algorithms now sift through seismic data, identifying patterns that might escape human analysts and potentially providing earlier warnings of impending events. Yet for all our technological progress, undersea earthquakes remain among the most powerful and unpredictable forces on our planet. They are reminders that beneath the seemingly placid surface of the ocean, tremendous energies are constantly building and releasing. reshaping the seafloor and occasionally unleashing destruction that crosses oceans to affect distant shores. When the next major undersea earthquake strikes, whether along the Cascadia subduction zone threatening the Pacific Northwest, the Manila Trench endangering densely populated parts of Southeast Asia, or some currently quiescent fault zone, the knowledge gained from studying previous events will be crucial in mitigating its impact. But the fundamental power of these submarine seismic events will remain awesome and humbling, a testament to the dynamic nature of our planet's hidden underwater landscapes. Now, let's illuminate a mysterious oceanic phenomenon that makes the sea glow with an otherworldly light. Story 21. Milky Sea, the ocean that glows like stars. From the violent tremors that reshape the ocean floor, we now turn to one of the most ethereal and mysterious phenomena found on the sea's surface, the Milky Sea. For centuries, sailors have reported encountering vast expanses of ocean that glow with an unearthly bluish-white light, transforming the dark waters into what appears to be a sea of milk or liquid stars stretching to the horizon. Unlike the brief, sparkle-like bioluminescence familiar to many coastal visitors, Milky Seas can cover thousands of square miles and persist for days or even weeks. Until recently, these accounts were dismissed as maritime folklore or exaggeration, but satellite imagery has now confirmed their existence, revealing that they are among the largest bioluminescent events on Earth. What causes these ghostly glowing waters? Why do they appear so rarely, and what might they tell us about the hidden microbiological processes occurring in our oceans? Few oceanic phenomena have inspired as much wonder and mysticism as the Milky Sea. Sailors' logs dating back to the 17th century contain descriptions of seas of milk and waters lit from below, with crews reporting the eerie experience of sailing through oceans that glowed with a steady, pale light extending from horizon to horizon. Unlike the familiar sparkles of bioluminescence that appear when water is disturbed, this glow was continuous, transforming night into a ghostly twilight that could last for days. One of the most famous historical accounts comes from Jules Verne's 20,000 Leagues Under the Sea, where Captain Nemo explains to Professor Aronnax. It's called a milk sea. The whitish appearance of this water is caused by the presence of myriads of tiny creatures, luminous animalcules, invisible to the naked eye, a sort of tiny glowworm whose number is incalculable. Verne's fictional description was based on real reports from mariners of his time, but the true nature of the phenomenon remained elusive for decades. What makes Milky Seas so different from typical marine bioluminescence is their scale and duration. Common bioluminescence is produced by dinoflagellates, single-celled organisms that emit brief flashes of blue light when disturbed, creating the sparkle effect seen in boat wakes or breaking waves. These displays rarely extend beyond a few hundred yards, and typically last only hours. In contrast, Milky Seas can cover up to 100,000 square kilometers, nearly 40,000 square miles, an area larger than South Korea, and persist for days or even weeks. The light they produce is steady rather than flashy, creating an even glow that sailors describe as bright enough to read by on otherwise moonless nights. For centuries, these accounts were treated with skepticism by the scientific community. The reported scale seemed implausible, and the phenomenon was rarely witnessed by trained observers. Without photographic evidence or scientific measurements, Milky Seas remained in the realm of maritime folklore alongside mermaids and sea serpents. That changed dramatically in 2005, when satellite evidence finally confirmed what sailors had been reporting for centuries. Dr. Stephen Miller of the Naval Research Laboratory was examining nighttime satellite imagery of the Indian Ocean when he noticed an unusual glow spanning approximately 15,400 square kilometers off the coast of Somalia. Correlating the image with shipping records, Miller found that a British merchant vessel, the SS Lima, had reported sailing through a Milky Sea in precisely that location, on the exact date the satellite image was captured. This breakthrough provided the first scientific confirmation of Milky Seas as a real, observable phenomenon, not just legends or exaggerated accounts. Subsequent satellite observations have identified additional events, primarily in the northwestern Indian Ocean and waters around Indonesia, with some instances also recorded near Java and off Somalia. But what actually causes these vast expanses of glowing ocean? The most widely accepted explanation centers on luminous bacteria, specifically Vibrio harveyi, also known as Vibrio fischeri. Unlike the dinoflagellates responsible for common bioluminescence, these bacteria don't produce brief flashes of light when disturbed. Instead, they emit a continuous glow through a process called quorum sensing. Essentially, the bacteria only activate their light-producing capability when they sense that their population has reached a critical mass. What remains puzzling is how these bacteria achieve the enormous concentrations necessary to illuminate such vast areas of ocean. Current theory suggests that Milky Seas form in association with massive blooms of algae or other microorganisms. As these blooms begin to decay, they create perfect conditions for luminous bacteria to colonize and multiply rapidly. The bacteria feed on the organic matter from the dying bloom, reaching population densities high enough to trigger their bioluminescent capabilities. This theory is supported by satellite analysis showing that many Milky Sea events follow significant algal blooms in the same regions. The bacteria essentially form a glowing biofilm on the ocean's surface, creating the impression of a sea that shines from within. Sailors who have encountered Milky Seas report a truly otherworldly experience. As ships move through the glowing waters, they describe leaving trails of darkness rather than light, the opposite of normal bioluminescence. Some accounts mention that the glow extends several meters deep, creating the unsettling impression of sailing through a vast pool of luminous milk or liquid stars. Beyond their visual splendor, Milky Seas may serve important ecological functions. The light produced by the bacteria could attract fish and other marine organisms, creating temporary feeding grounds in otherwise nutrient-poor areas of the open ocean. Some researchers theorize that the light might also serve as a kind of biological communication system between microbial communities, possibly signaling favorable conditions or coordinating group behaviors across vast distances. The rarity of Milky Seas adds to their mystery. Despite covering enormous areas, they occur infrequently and unpredictably, making them difficult to study directly. Most documented events have occurred in remote areas of the Indian Ocean, far from major shipping lanes or research facilities. By the time scientists could mobilize to study a reported Milky Sea, it would typically have dissipated, leaving behind few traces of its existence. This changed in 2019, when a research vessel carrying ocean scientists from Colorado State University happened to encounter a Milky Sea in the East Indian Ocean near Java. For the first time, researchers were able to collect water samples directly from an active Milky Sea event, confirming the presence of high concentrations of luminous bacteria. The team described sailing through waters that glowed like the Milky Way, lit from beneath, with the glow extending from horizon to horizon. The research team's findings supported the prevailing theory about bacterial colonization of decaying algae blooms, but also raised new questions. The concentration of bacteria needed to produce such extensive illumination is staggering, potentially trillions of organisms per square meter of ocean surface. How these bacteria coordinate their light production across such vast distances remains poorly understood. Climate change and ocean warming may be affecting the frequency and distribution of Milky Seas. As sea temperatures rise and ocean circulation patterns shift, the conditions that support massive algal blooms, the precursors to Milky Seas, are changing. Some regions may experience more frequent blooms, potentially increasing Milky Sea occurrences, while other areas may see declines in these events. For mariners, encountering a Milky Sea has always been considered an omen, though whether good or bad varies across seafaring cultures. In some traditions, sailing through glowing waters was seen as a blessing or sign of divine favor. In others, particularly among Persian Gulf sailors, the phenomenon was feared as a harbinger of danger or a manifestation of angry sea spirits. These cultural interpretations reflect how Milky Seas challenge our perception of natural boundaries. The ocean, normally dark and impenetrable at night, suddenly becomes luminous, inverting our expectations and creating a liminal space where the familiar becomes strange. It's no wonder that sailors throughout history have attached supernatural significance to these events. Modern satellite technology now allows scientists to identify and track Milky Seas with unprecedented precision. The day-night band of the visible infrared imaging radiometer suite instrument aboard weather satellites can detect the faint glow of these bioluminescent events from orbit, distinguishing them from other light sources like fishing fleets or moonlight reflected on clouds. This capability has revealed that Milky Seas are more common than previously thought, with dozens of events identified in satellite imagery since 2012. Most occur in specific regions and seasons, particularly during late summer monsoon periods in the northwestern Indian Ocean. This pattern suggests that specific oceanographic conditions, perhaps related to upwelling nutrients, water temperature, or current patterns, favor their formation. Scientists are now working to develop predictive models for Milky Sea events, combining satellite observations with oceanographic data to understand the precise conditions that trigger these massive bioluminescent blooms. If successful, these models could help direct research vessels to future events, allowing for more comprehensive study of this elusive phenomenon. Beyond their scientific interest, Milky Seas offer a profound reminder of how much remains unknown about our oceans. That a phenomenon covering tens of thousands of square kilometers could remain scientifically unconfirmed until the 21st century highlights the vast gaps in our understanding of marine processes, particularly those involving microbial communities. The bacteria responsible for Milky Seas represent just a tiny fraction of the ocean's microbial diversity. Marine microorganisms make up over 90% of the ocean's biomass and drive global nutrient cycles, yet we've identified only a small percentage of these species. The unexpected behaviors and capabilities of luminous bacteria in Milky Seas suggest that countless other microbial mysteries await discovery in the world's oceans. For sailors fortunate enough to witness a Milky Sea, the experience remains profound and humbling. As one modern captain described it, the sea was white like falling snow. The bow wave and wake glowed with such intensity that you could clearly read the ship's name from the stern. It was as if we were sailing through a field of stars, with our vessel leaving a dark pathway behind it. In 30 years at sea, I've never seen anything like it before or since. This sense of wonder echoes through centuries of maritime accounts, connecting modern observers to sailors from generations past who found themselves suddenly sailing through an ocean transformed into liquid light. In a world increasingly mapped, measured, and understood, Milky Seas remain a reminder that the planet's most massive environment, the global ocean, still holds phenomena capable of inspiring awe and challenging our understanding of the natural world. As satellite monitoring improves and research vessels deploy with better instruments and sampling techniques, we may soon unravel more of the mysteries surrounding Milky Seas. But something of their magic will always remain. The extraordinary experience of witnessing the boundary between sea and sky dissolve in a gentle, all-encompassing glow that transforms the fearsome nighttime ocean into a luminous otherworld, a sea of stars that sailors navigate with wonder and reverence. Now, let's dive toward one of the Baltic Sea's most puzzling underwater discoveries. Story 22. Baltic Sea Anomaly, UFO, or natural formation. From the ethereal glow of the Milky Sea, we now dive into one of the most controversial underwater discoveries of the 21st century, the Baltic Sea Anomaly. In 2011, Swedish treasure hunters using side-scan sonar identified a strange circular object resting on the seafloor, approximately 300 feet below the surface. The sonar image revealed what appeared to be a perfectly circular formation about 200 feet in diameter with unusual structural features. What made this discovery immediately go viral were the object's uncanny resemblances to the fictional Millennium Falcon from Star Wars, or more ominously, to a crashed flying saucer. Despite numerous expeditions to the site, the true nature of the Baltic Sea anomaly remains fiercely debated. Is it a natural geological formation, a man-made structure from a forgotten civilization, or, as some continue to insist, evidence of something truly otherworldly? Let's examine the evidence behind one of the ocean's most polarizing mysteries. The story of the Baltic Sea anomaly begins with Oceanic's team, a group of Swedish treasure hunters led by Peter Lindberg and Dennis Osberg. The team had been searching the Baltic Sea for shipwrecks and valuable historical artifacts when their side-scan sonar captured an unusual image approximately 60 miles from the Swedish coast between Sweden and Finland. The object appeared as a nearly perfect circle with straight lines, right angles, and features that seemed oddly symmetrical and structured. When OceanX released their sonar images to the public in 2011, the response was immediate and dramatic. UFO enthusiasts and alternative researchers quickly seized on the discovery, noting its resemblance to depictions of flying saucers. The object's circular shape, approximately 200 feet in diameter, along with what appeared to be a trail or skid mark extending behind it for about 900 feet, suggested to some that this might be a crashed extraterrestrial craft. Adding to the intrigue, the Ocean X team reported equipment malfunctions when approaching the site. "Anything electric out there stopped working when we were above the object," claimed diver Stefan Hogerborn, a professional diver working with the team. "And then when we got away about 200 meters, it turned on again." This detail, reminiscent of science fiction depictions of electromagnetic interference from alien technology, further inflamed speculation about the object's origins. In 2012, the Ocean X team returned to the site with better equipment and a documentary film crew. During this expedition, divers managed to explore the object directly, collecting samples and capturing video footage. What they found was an undeniably strange formation, a raised circular feature with angular structures, straight edges, and unusual textures unlike the surrounding seafloor. The samples collected from the object were later analyzed and determined to contain high concentrations of metals, including iron, manganese, and limonite. Some team members and associated researchers claimed these metal concentrations were inconsistent with natural geological formations, suggesting artificial or even extraterrestrial origins. Others pointed to the object's unusual shape, noting what appeared to be staircase-like features, doorways, and even what some interpreted as inscriptions or symbols embedded in its surface. However, mainstream scientific response to the Baltic Sea anomaly has been overwhelmingly skeptical. Geologists examining the available evidence have proposed several natural explanations for the formation, with the most widely accepted being that it represents a glacial deposit, essentially a large rock or collection of rocks deposited by retreating glaciers at the end of the last ice age, approximately 10,000 to 14,000 years ago. Professor Volker Bruchert of Stockholm University, who examined stone samples from the site, concluded, "I believe it is a natural, geological formation." He noted that the samples appeared to be granitic in nature, consistent with glacial deposits common throughout the Baltic region. Other geologists have suggested the formation might be a moraine, accumulated glacial debris, an ancient volcanic plug, or even a natural gas well structure. The reported equipment malfunctions, a key element in more exotic interpretations of the anomaly, have also been questioned by skeptics. The Baltic Sea contains some of the world's largest dead zones, areas of water with extremely low oxygen content resulting from pollution and natural factors. These dead zones create unusual chemical conditions that can potentially interfere with electronic equipment, offering a natural explanation for the reported failures. As for the object's distinctive circular shape and seemingly artificial features, many geologists point to natural processes that can create surprisingly geometric formations. Concretions, compact masses of mineral matter that form within sedimentary rock, can create spherical or disc-shaped structures with internal patterns that may appear artificial when partially exposed. Similarly, columnar basalt formations like the Giant's Causeway in Ireland demonstrate how natural processes can create remarkably geometric and seemingly designed structures. Adding to the controversy is the limited quality of evidence available for independent scientific analysis. Much of the video footage from the site is low resolution and murky due to the Baltic Sea's poor visibility. The sonar images that initially captured public imagination have been criticized as potentially misleading, as side-scan sonar can distort underwater features and create illusory patterns depending on the angle of scanning and processing methods used. Despite these scientific explanations, public fascination with the Baltic Sea anomaly has persisted, fueled by television documentaries, websites, and social media discussions. The object has become a flashpoint in debates between mainstream scientific interpretation and alternative researchers who contend that established science is too quick to dismiss anomalous discoveries. Some proponents of more exotic explanations suggest the object could be a remnant of an ancient advanced civilization, pointing to legends of sophisticated pre-Ice Age cultures like Atlantis. Others maintain the extraterrestrial hypothesis, arguing that the object's unusual features and reported effects on electronic equipment cannot be adequately explained by natural geological processes. The Baltic Sea region does have a rich archaeological history that complicates interpretation of underwater discoveries. During the last ice age, much of the area now covered by the Baltic Sea was dry land, inhabited by prehistoric human populations. As the ice sheets retreated and sea levels rose, these ancient landscapes were gradually submerged, potentially preserving artifacts and structures from these early settlements. Numerous significant archaeological finds have been made in the Baltic, including shipwrecks dating back to the Viking era and even earlier. This historical context has led some researchers to propose more moderate alternative explanations for the anomaly. Could it be a submerged ancient monument similar to Stonehenge? Might it represent the remains of a prehistoric settlement, perhaps with ceremonial or astronomical significance? Or could it even be a relatively modern structure, such as a World War II-era defensive installation or a secretive Cold War device abandoned on the seafloor? What makes the Baltic Sea anomaly particularly challenging to investigate is its location and environment. The Baltic Sea has some of the most difficult diving conditions in the world. Low visibility, often less than 3 feet, cold temperatures, and the object's depth, approximately 300 feet, make exploration dangerous and technically challenging. Extended investigations using advanced equipment like remotely operated vehicles would be necessary for comprehensive documentation, requiring funding beyond what private treasure hunting groups like Oceanic's team can typically access. Mainstream archaeological and scientific institutions have shown limited interest in mounting such expensive expeditions to investigate what most professionals consider a likely natural formation. This lack of comprehensive scientific investigation has created an information vacuum that allows speculation to flourish. The story of the Baltic Sea anomaly highlights several recurring patterns in how underwater discoveries are interpreted and understood. First, it demonstrates the powerful influence of cultural imagery on perception. The initial sonar scans' resemblance to the Millennium Falcon from Star Wars and popular depictions of flying saucers primed many observers to see the object in terms of these familiar references, making it difficult to approach the discovery without preconceived notions. Second, it illustrates how underwater discoveries often receive less rigorous scientific scrutiny than their land-based counterparts. Investigating sites underwater is exponentially more expensive and logistically challenging than excavating on land, meaning that unusual formations or potential archaeological sites beneath the waves may go understudied for decades or longer. Finally, the Baltic Sea anomaly demonstrates the enduring tension between established scientific methodology and alternative research approaches. While mainstream science demands verifiable evidence, controlled studies, and peer review, alternative researchers often emphasize patterns, anomalies, and phenomena that don't fit neatly into existing frameworks. Both approaches have their strengths and limitations, but underwater discoveries like the Baltic Sea anomaly often become battlegrounds between these differing epistemological approaches. In recent years, the controversy surrounding the anomaly has somewhat subsided, though interest remains among certain communities. Oceanic's team has conducted additional expeditions to the site, continuing to document the strange formation and occasionally releasing new photographs or video clips that reignite public curiosity. The scientific consensus remains that the Baltic Sea anomaly is most likely a natural geological formation, albeit an unusual one. The circular shape, seemingly straight edges, and right angles that appear so striking in the original sonar image have been attributed to the limitations of sonar technology rather than the actual physical characteristics of the object itself. When viewed through clearer video footage, many of the formation's supposedly artificial features appear less geometric and more consistent with natural rock formations. However, without a comprehensive scientific expedition using state-of-the-art equipment to thoroughly document, map, and sample the site, a definitive explanation remains elusive. The remote location, difficult diving conditions, and lack of institutional interest ensure that the Baltic Sea anomaly will likely remain in a limbo of competing interpretations for the foreseeable future. For maritime explorers and underwater archaeologists, the Baltic Sea anomaly serves as a reminder of how much of our ocean floor remains unmapped and unexplored. While we have detailed maps of Mars and the Moon, only about 20% of the Earth's seafloor has been mapped at high resolution. In this context, strange and unexpected discoveries beneath the waves are not just possible but inevitable. Whether the Baltic Sea anomaly ultimately proves to be a fascinating but natural geological curiosity, an important archaeological site, or something more extraordinary, its discovery has sparked valuable conversations about how we interpret underwater anomalies and what standards of evidence we require before drawing conclusions about such findings. As technology improves and becomes more accessible, allowing more comprehensive mapping and exploration of the seafloor, we can expect more such discoveries in the future. Each will present its own interpretive challenges, asking us to balance open-minded curiosity against rigorous scientific analysis as we continue to unveil the secrets hidden beneath the waves. Until a definitive explanation emerges, the Baltic Sea anomaly will remain what it has been since its discovery, a compelling mystery that reminds us how the ocean floor, Earth's last great unexplored frontier, still has the capacity to surprise us and challenge our understanding of the world beneath the waves. Don't let this underwater mystery sink without a trace. Catch it with a quick subscribe. Unlike the Baltic Sea anomaly, there's nothing mysterious about the benefits of hitting that button. Your subscription acts as a sonar ping that helps our channel navigate through the vast ocean of content, ensuring these fascinating maritime enigmas continue to surface in your feed. Now, let's sail toward one of the most famous ghost ships in maritime history. Story 23. Mary Celeste Ship, the ghost vessel's enduring mystery. From the controversial Baltic Sea anomaly, we now drift toward one of history's most enduring maritime mysteries, the ghost ship Mary Celeste. On December 4th, 1872, this American merchant vessel was discovered adrift in the Atlantic Ocean, approximately 400 miles east of the Azores. The ship was in perfect sailing condition, with ample supplies and valuable cargo untouched. But everyone aboard, 10 people, including Captain Benjamin Briggs, his wife, young daughter, and 7 experienced crew members, had vanished without a trace. What force could compel an experienced captain to abandon a seaworthy vessel, taking his family and crew into the dangerous open ocean rather than remaining safely aboard? Despite nearly 150 years of investigation, debate, and speculation, the fate of the Mary Celeste passengers and crew remains one of the ocean's most baffling unsolved mysteries, spawning theories ranging from piracy and mutiny to supernatural forces and underwater earthquakes. The mystery begins with the Mary Celeste herself, a 103-foot brigantine built in Nova Scotia in 1861. Originally christened the Amazon, the vessel had already developed a reputation for misfortune before her most famous voyage. During her early career, the ship's first captain died unexpectedly. She collided with another vessel in the English Channel and ran aground on at least one occasion. After being salvaged and renamed the Mary Celeste in 1869, the ship came under the command of Captain Benjamin Briggs, an experienced and well-respected mariner from Massachusetts. On November 7, 1872, the Mary Celeste departed New York Harbor bound for Genoa, Italy. Her cargo consisted of 1,701 barrels of denatured alcohol, a valuable but potentially dangerous cargo due to its flammability. On board were Captain Briggs, his wife Sarah, their 2-year-old daughter Sophia, and a crew of 7 experienced sailors. By all accounts, Briggs was a capable captain, a family man, and a teetotaler who ran a tight ship and wouldn't have brought his wife and young daughter aboard if he had any concerns about the vessel's seaworthiness or the journey ahead. About a week after the Mary Celeste's departure, another vessel left New York bound for Gibraltar, the British ship Dei Gratia, commanded by Captain David Morehouse. Morehouse was an acquaintance of Briggs, and the 2 captains had reportedly dined together shortly before their respective departures. The Dei Gratia was following a similar route to the Mary Celeste but had left port several days later. On December 4th, 1872, approximately 400 miles east of the Azores, lookouts aboard the Dei Gratia spotted a vessel behaving erratically in the distance. As they drew closer, they recognized the ship as the Mary Celeste, but something was clearly wrong. The brigantine was yawing strangely, her sails were improperly set for the wind conditions, and most alarming, there appeared to be no one on deck. Captain Morehouse ordered a boarding party to investigate. What the sailors from the Dei Gratia discovered upon boarding the Mary Celeste has become the stuff of maritime legend, a ghost ship in seemingly perfect condition but completely abandoned. The vessel was seaworthy with only moderate water in her bilge, normal for a ship of her age. Her cargo was intact, and the crew's personal belongings, including clothing and valuables, remained undisturbed. In the captain's cabin, they found Briggs's navigational instruments, except for his sextant and chronometer, and the ship's logbook, with the last entry dated November 25th, 9 days before the vessel was discovered adrift. The boarding party noted several curious details. The ship's single lifeboat was missing, suggesting a deliberate evacuation rather than passengers and crew being swept overboard. A rope was found hanging over the side of the vessel, The ship's clock and chronometer were not working, and the compass had been damaged. Most notably, investigators later discovered that the last entry in the ship's log placed the Mary Celeste about 400 miles west of where she was actually found, indicating she had continued sailing for several days after the final log entry, apparently without anyone at the helm. What was not found aboard the Mary Celeste proved equally significant. There were no signs of violence or struggle, no bloodstains, no evidence of fire or explosion, and no indication of piracy or criminal activity. Captain Morehouse arranged for a skeleton crew to sail the seemingly cursed vessel to Gibraltar, where maritime authorities conducted a formal inquiry into the mysterious circumstances. The Gibraltar Salvage Court proceedings, led by British Admiralty Judge Frederick Solly Flood, initially treated the case with suspicion, even suggesting that the crew of the Dei Gratia might have been involved in foul play to claim salvage rights. However, after extensive investigation, no evidence of wrongdoing was found, and the court eventually awarded the Dei Gratia crew a salvage payment, albeit a relatively small one due to the lingering cloud of suspicion. Since then, generations of investigators, from Arthur Conan Doyle, who fictionalized the mystery in his short story J. Plank's Habakkuk Jeffson's Statement, to modern maritime historians, have proposed numerous theories to explain the Mary Celeste's abandonment. Each theory attempts to answer the central question: what could have been so terrifying that an experienced captain would choose to evacuate his ship, taking his wife and infant daughter into the dangerous open ocean in a small lifeboat, rather than remain aboard a seaworthy vessel? One of the most plausible explanations centers on the ship's cargo of industrial alcohol. 9 of the 1,701 barrels were later discovered empty when the ship reached port. Investigators have suggested that fumes from the alcohol might have escaped through the barrel seams, filling the hold with vapor that the crew feared might explode. In a panic, Captain Briggs might have ordered everyone into the lifeboat, perhaps intending to trail behind the ship until the perceived danger had passed. If the Mary Celeste then surged ahead unexpectedly, or if the rope connecting the lifeboat broke, the occupants would have been left adrift in the vast Atlantic, where their chances of survival would have been minimal. Modern scientific testing has lent some credence to this theory. In 2006, an experiment conducted for a documentary demonstrated that alcohol fumes could indeed create an explosive pressure wave without leaving behind evidence of fire or heat damage. Such an event might have terrified the crew into abandoning ship, only to have the threat literally dissipate into the air after they'd left. Weather conditions offer another potential explanation. The Mary Celeste had encountered rough seas and may have been struck by a waterspout or seaquake, an underwater earthquake that can create sudden, violent turbulence even in otherwise calm waters. Such phenomena were poorly understood in the 19th century and might have convinced Captain Briggs that his ship was breaking apart or sinking, prompting a desperate evacuation. Supporting this theory, the vessel was found with damage to its bow and evidence that it had been temporarily submerged underwater with enough force to shatter the ship's clock. If the crew believed the vessel was foundering, they might have abandoned ship in haste, only for the Mary Celeste to right herself and continue sailing without them. More controversial theories include piracy or mutiny, though the undisturbed cargo and valuables left aboard argue strongly against these explanations. The waters where the Mary Celeste was found were not known for pirate activity in the 1870s, and the crew had been carefully selected by Captain Briggs and had excellent reputations. Some researchers have pointed to the possibility of contaminated food or water leading to hallucinations or irrational behavior. Ergot poisoning, which can cause convulsions and psychosis, has been suggested as a potential culprit. If the ship's bread supply had been contaminated with this fungus, it could have caused the crew to experience terrifying hallucinations, potentially leading to mass panic and abandonment of the vessel. The more far-fetched explanations include alien abduction, sea monsters, and supernatural forces. While these theories have fueled the Mary Celeste's legendary status in popular culture, they lack any supporting evidence beyond the mysterious circumstances of the disappearance itself. Perhaps the most haunting aspect of the Mary Celeste mystery is that the fate of her passengers and crew will likely never be known with certainty. No trace of the lifeboat or its occupants was ever found, despite extensive searching. No bodies washed ashore on nearby islands. The 10 people aboard the Mary Celeste, including young Sophia Briggs, simply vanished, becoming permanent residents of maritime legend. The aftermath of the Mary Celeste incident saw the vessel return to service under new owners, but her reputation as a cursed ship followed her. She changed hands multiple times, with owners routinely losing money on their investment. Her career ended in 1885, and perhaps the only fitting conclusion to her troubled history. Her last captain deliberately ran her aground off Haiti as part of an insurance fraud scheme. The attempt failed when the ship didn't break up as planned, and the fraud was discovered. The Mary Celeste was left to disintegrate slowly on a Caribbean reef, an ignominious end for a vessel of such notorious fame. The legacy of the Mary Celeste extends far beyond her physical remains. Her name has become synonymous with inexplicable disappearances and abandoned vessels. The term Mary Celeste is now used to describe any situation where people vanish suddenly and without explanation, leaving behind an eerily undisturbed scene. Her story has inspired countless novels, films, and television episodes, each offering their own interpretation of what might have happened during those fateful days in 1872. For maritime historians, the Mary Celeste represents a perfect storm of circumstances, a genuine historical mystery with enough documented facts to make it credible but sufficient gaps in the record to render a definitive explanation impossible. The ship's logbook ends on November 25th, but the vessel wasn't discovered until December 4th, leaving 10 crucial days unaccounted for. What happened during this period remains forever hidden by the passage of time and the silence of the sea. Even with modern technology and investigative techniques, cold cases from the 19th century present nearly insurmountable challenges. Physical evidence has long since disappeared, witnesses are no longer alive to interview, and contemporary accounts are often colored by sensationalism or the limited scientific understanding of the era. We can speculate and theorize, but the complete truth about what happened aboard the Mary Celeste in those final days may remain forever beyond our reach. Yet this very elusiveness continues to captivate us. The Mary Celeste endures as one of history's greatest maritime enigmas precisely because it resists definitive explanation. In an age where mystery seems increasingly scarce, where satellites track every vessel and instant communication is taken for granted, the story of a ship found adrift and abandoned in the vast Atlantic, its crew vanished without a trace, reminds us that the ocean still holds secrets, some of which may never be revealed. As we reflect on the ghost ship Mary Celeste, we confront one of the most unsettling aspects of the oceanic unknown, the possibility that some mysteries may remain permanently unsolved, drifting through history like the abandoned brigantine herself, forever sailing the currents of human curiosity and imagination. Now, let us navigate toward another bewildering oceanic phenomenon that defies conventional physics. Story 24: High-frequency gravity waves, the ocean's invisible roller coaster. From the haunting abandonment of the Mary Celeste, we now turn to an ocean phenomenon so recently discovered that many oceanographers are still debating its significance and mechanisms: high-frequency gravity waves. Unlike the familiar surface waves that surfers ride, or the massive internal waves that move through the ocean's depths, these mysterious oscillations exist in a frequency range once thought impossible, according to classical wave theory. Detected only in the past few decades using advanced pressure sensors and satellite measurements, high-frequency gravity waves create invisible but powerful forces beneath the surface, potentially explaining reports of sudden rogue holes in the ocean where ships experience catastrophic loss of buoyancy. What causes these strange waves that seem to defy traditional physics? How might they contribute to unexplained maritime disasters? And what do they reveal about how much we still have to learn about the fundamental dynamics of our oceans? The ocean is often portrayed as having a clearly defined hierarchy of wave motions. The surface waves we can see breaking on shores, longer tsunami waves that race across entire ocean basins, and slow-moving internal waves that propagate through the ocean's interior along density boundaries. This orderly categorization of ocean waves, developed over centuries of observation and mathematical analysis, seemed complete until relatively recently. In the late 1990s, however, oceanographers began detecting unusual pressure oscillations in the deep ocean that didn't fit within this established framework. These variations occurred at frequencies that traditional wave theory suggested couldn't exist, too fast for internal waves but too slow and deep for normal surface waves. The discovery challenged fundamental assumptions about ocean dynamics and opened an entirely new field of research. High-frequency gravity waves occupy a curious middle ground in the spectrum of ocean motion. They're typically characterized by periods ranging from minutes to hours, faster than internal waves that might take days to cross an ocean basin. but much slower than wind-driven surface waves with periods measured in seconds. What makes them particularly significant is that they can carry substantial energy and momentum through the water column, potentially affecting everything from marine ecosystems to submarine operations. Unlike surface waves that we can observe directly, high-frequency gravity waves remain invisible to the naked eye. They manifest as subtle but rapid changes in pressure, temperature, and current velocity at various depths. Detecting them requires sophisticated instrumentation, including pressure sensors capable of measuring minute variations, acoustic Doppler current profilers that track water movement, and satellite systems that can observe their indirect effects on the ocean's surface. The mechanisms behind these waves remain a subject of active research and debate. Several potential generation processes have been proposed, each with varying degrees of scientific support. One leading theory suggests they result from the interaction between tidal flows and underwater topography like seamounts, ridges, or continental shelves. As powerful tidal currents encounter these obstacles, they create disturbances that propagate through the water column at frequencies higher than traditional internal waves. Another possibility involves atmospheric forcing, rapid changes in air pressure or wind patterns that transfer energy to the ocean in complex ways. Storms, frontal systems, and atmospheric gravity waves, their airborne counterparts, could potentially trigger corresponding oscillations within the ocean. This air-sea coupling might explain why some high-frequency gravity waves appear correlated with weather patterns. Perhaps most intriguing is the theory that these waves may result from nonlinear interactions between different oceanic processes. Just as musical instruments can produce harmonics, frequencies that are multiples of the fundamental tone, ocean waves might combine and resonate to generate higher frequency components. This nonlinear cascading of energy across different scales could produce wave motions in frequency ranges previously thought impossible. For mariners, high-frequency gravity waves represent a potential hazard unlike any other. While they don't create visible surface disturbances like breaking waves or whitecaps, they can cause rapid, unpredictable changes in the ocean's vertical structure. This has led some researchers to connect these waves to reports of rogue holes, sudden, localized drops in sea level that can cause ships to lose buoyancy catastrophically. Reports of such phenomena date back centuries in maritime lore, with sailors describing encounters with sections of ocean that seem to open up beneath their vessels, causing ships to plunge downward before the water returned to normal. Traditionally dismissed as exaggerations or myths, these accounts have gained new credibility as our understanding of high-frequency gravity waves has developed. Mathematical models suggest that under certain conditions, these waves could create temporary but significant depressions in the ocean's surface, potentially explaining these historical accounts. One particularly compelling case occurred in 1995 when the cruise ship Queen Elizabeth II encountered what the captain described as a wall of water in the North Atlantic. Contrary to initial reports describing this as a rogue wave, an abnormally large surface wave, later analysis suggested the ship may have experienced a high-frequency gravity wave phenomenon that temporarily altered the ocean structure beneath the vessel. The ship dropped suddenly into a trough before rising again, resulting in injuries to passengers and damage to the vessel. For submarines and underwater vehicles, high-frequency gravity waves present even greater challenges. These craft rely on maintaining precise depth control through careful buoyancy adjustments. A passing high-frequency gravity wave could rapidly alter the density structure of surrounding water, potentially forcing a submarine above or below its intended depth. In military contexts, where remaining at a specific depth might be crucial for stealth or mission success, such unpredictable vertical displacements could prove disastrous. The scientific significance of high-frequency gravity waves extends beyond maritime safety concerns. These waves represent an important mechanism for energy transfer within the ocean, potentially contributing to mixing processes that affect nutrient distribution, heat transport, and even climate dynamics. Understanding their behavior and distribution could improve our models of ocean circulation and climate systems. Biologically, these waves might influence marine ecosystems in ways we're only beginning to comprehend. Many marine organisms, from plankton to large predators, respond to changes in pressure, temperature, and current patterns. High-frequency gravity waves could trigger vertical migrations, feeding behaviors, or physiological responses in marine life, creating ripple effects throughout ocean food webs. Recent advances in observation technology have dramatically improved our ability to detect and study these elusive phenomena. Arrays of pressure sensors deployed across the deep ocean floor can now capture wave signals with unprecedented resolution. Autonomous underwater vehicles equipped with sophisticated instruments traverse the oceans, collecting data on water column properties. And satellite systems like the Surface Water and Ocean Topography mission can observe subtle variations in sea surface height that may correlate with high-frequency wave activity below. As our observational capabilities have improved, so too has our understanding of where and when these waves are most prevalent. Certain regions appear to be hotspots for high-frequency gravity wave activity, particularly areas with complex underwater topography, strong tidal currents, or frequent storm activity. The continental slopes off North America, the waters around Hawaii, parts of the Southern Ocean, and the Luzon Strait between Taiwan and the Philippines have all emerged as regions of intense high-frequency wave generation. Seasonal patterns have also become apparent, with wave activity often peaking during periods of strong storm systems, or when astronomical conditions create particularly powerful tides. These temporal patterns provide valuable information for mariners and researchers attempting to predict when and where high-frequency gravity waves might pose the greatest risk. For oceanographers, the discovery of high-frequency gravity waves represents a humbling reminder of how incomplete our understanding of ocean physics remains. That a major class of wave motions could remain essentially unknown until the late 20th century suggests that other significant phenomena may still await discovery in the world's oceans. This realization has prompted a reevaluation of classical wave theory and a renewed appreciation for the ocean's complexity. Looking to the future, research into high-frequency gravity waves continues to evolve rapidly. Advanced computer models now attempt to simulate their generation and propagation, incorporating increasingly sophisticated physics to capture their behavior. New observational networks expand our knowledge of their global distribution and characteristics, and interdisciplinary studies explore their impacts on everything from marine ecology to submarine navigation. For the average ocean traveler, high-frequency gravity waves remain an invisible presence, felt perhaps as an unusual motion of their vessel or an unexpected change in conditions, but rarely understood as a distinct phenomenon. Yet as our knowledge grows, so too does our ability to predict, prepare for, and potentially mitigate the risks they pose to maritime activities. In the meantime, these waves stand as a powerful reminder that the ocean, for all our centuries of exploration and scientific advancement, still harbors fundamental mysteries. Beneath its surface, invisible forces continue to shape water movements in ways we're only beginning to comprehend. A hidden roller coaster of energy and motion that occasionally makes its presence known through the sudden, unexpected experiences of those who venture across the sea. Now, let's illuminate a spectacular oceanic light show that transforms nighttime waters into a glowing spectacle. Story 25: Bioluminescent Waves, the ocean's living light show. From the invisible oscillations of high-frequency gravity waves, we now turn to one of the ocean's most spectacularly visible phenomena, bioluminescent waves. Imagine walking along a beach at night, when suddenly each breaking wave erupts in electric blue light, transforming the dark shoreline into a scene that seems more science fiction than reality. These glowing waves aren't the product of chemical pollution or radiation, as some mistakenly believe, but rather one of nature's most magical displays, living light produced by billions of tiny marine organisms. What causes these stunning light shows? Why do they occur in some locations but not others? And what insights do they offer into the complex microscopic ecosystems that drive oceanic processes? Let's dive into the fascinating world of bioluminescent waves, where chemistry, biology, and oceanography combine to create one of the sea's most breathtaking spectacles. Few natural phenomena inspire as much wonder as witnessing the ocean glow with an ethereal blue light. These living light shows transform ordinary coastlines into otherworldly landscapes, where each wave crash, footstep on wet sand, or hand swept through the water leaves a trail of glowing blue that seems almost magical in its beauty. But the science behind bioluminescent waves is every bit as fascinating as their appearance. The primary architects of this spectacle are typically single-celled marine organisms called dinoflagellates, a type of plankton so small that millions can fit in a single liter of seawater. Despite their microscopic size, when present in sufficient numbers, These tiny creatures collectively produce light displays visible from miles away. The most common bioluminescent species, Noctiluca scintillans, often called sea sparkle, can reach concentrations of millions of cells per gallon of seawater during peak blooms. Unlike the steady glow of a light bulb, bioluminescent dinoflagellates produce light only when mechanically stimulated, disturbed by the motion of breaking waves, swimming fish, or human activity. This mechanism evolved as a defense strategy. When a predator attempts to consume the dinoflagellates, their flash of light startles the attacker, or potentially attracts larger predators that might target the dinoflagellate's would-be consumer. It's an ingenious evolutionary adaptation that transforms their microscopic vulnerability into a powerful defense through collective action. The biochemistry behind this living light is remarkably efficient. Dinoflagellates contain a protein called luciferase and a compound called luciferin. When the cell is physically disturbed, these chemicals mix in the presence of oxygen, creating a brief chemical reaction that releases energy in the form of blue light. This process, called bioluminescence, is one of the most efficient light-producing mechanisms known to science, converting nearly 100% of the chemical energy into light with almost no heat generation, far more efficient than any human-made lighting technology. What makes bioluminescent waves particularly spectacular is their timing and location. These displays don't occur randomly, but follow complex patterns influenced by oceanographic, seasonal, and biological factors. In many regions, bioluminescent waves are highly seasonal, appearing for just a few weeks or months each year when conditions align perfectly for dinoflagellate blooms. The Maldives' famous Sea of Stars typically peaks between July and December, while Puerto Rico's bioluminescent bays maintain year-round displays due to their unique geography that traps and concentrates the glowing organisms. California's occasional red tides, which often produce nighttime blue bioluminescence, typically occur in late summer and early fall, when water temperatures and nutrient conditions favor massive dinoflagellate blooms. Geography plays a crucial role in where these displays occur. The most reliable and intense bioluminescent waves typically form in protected bays, lagoons, and coastal areas where dinoflagellates can concentrate without being dispersed by strong currents. Phosphorescent Bay in Vieques, Puerto Rico stands as perhaps the world's most famous bioluminescent bay, where the narrow entrance and shallow depth create ideal conditions for the light-producing organisms to flourish year-round. Mosquito Bay, also in Puerto Rico, holds the Guinness World Record for the brightest bioluminescent bay, with dinoflagellate concentrations reaching up to 160,000 cells per liter of water. The bay's restricted water exchange with the ocean, combined with the surrounding mangrove trees that release vitamin B12, essential for dinoflagellate growth, creates perfect conditions for these living light producers. What many observers find most surprising about bioluminescent waves is their unpredictability in most locations. Even in areas known for these displays, the intensity can vary dramatically from night to night, or even hour to hour. A beach might showcase spectacular blue waves one evening and appear completely normal the next. This variability stems from the complex interaction of factors influencing dinoflagellate populations and behavior. Water temperature, nutrient availability, wind conditions, lunar cycles, and recent rainfall can all affect bioluminescent intensity. Heavy rainfall, for instance, can wash additional nutrients into coastal waters, potentially fueling dinoflagellate blooms days later. Conversely, strong storms can disperse concentrated populations, temporarily diminishing the light show. Even the moon plays a role. Bioluminescence appears most vivid on moonless nights, when the contrast between the glowing waves and dark surroundings is greatest. For mariners throughout history, bioluminescent waters have inspired both wonder and practical applications. Ancient sailors used these glowing wakes to track fish movements and navigate at night. Indigenous peoples in bioluminescent-rich regions incorporated these light displays into their mythologies and cultural practices. The Taino people of Puerto Rico, for instance, believed the bioluminescent bays were where the creator goddess Atabay bathed, imbuing the waters with her divine energy. More recently, scientists have discovered that bioluminescent waves can serve as important indicators of ocean health and changing marine conditions. While some bioluminescent blooms occur naturally as part of healthy marine ecosystems, unusually intense or frequent displays can sometimes signal ecological imbalances. When coastal waters receive excessive nutrients from agricultural runoff or urban pollution, certain dinoflagellate species can bloom in unnaturally high concentrations, sometimes leading to harmful algal blooms that produce toxins dangerous to marine life and humans. This connection between bioluminescence and harmful algal blooms represents a complex ecological relationship. Not all bioluminescent species produce toxins, and not all toxic algal species produce light. However, some of the most common bioluminescent dinoflagellates, including certain Alexandrium and Lingulodynium species, can produce potent neurotoxins during massive blooms. These toxins can accumulate in shellfish and fish, causing paralytic shellfish poisoning in humans who consume them. The study of bioluminescent waves has expanded beyond their inherent beauty to include their potential as early warning systems for coastal ecosystem health. Changes in the timing, intensity, or species composition of bioluminescent blooms may indicate shifting ocean conditions, including warming waters due to climate change, changing nutrient patterns, or other human influences. Beyond their ecological significance, bioluminescent organisms have become valuable tools in scientific research and medical applications. The genes that code for luciferase, the light-producing enzyme in bioluminescent creatures, have been isolated and incorporated into laboratory techniques that revolutionize biological research. Scientists use these bioluminescent markers to track cellular processes, study gene expression, and visualize the progression of diseases like cancer. The same chemical reaction that creates glowing waves on a beach now helps develop life-saving medical treatments and advances our understanding of human biology. For travelers and coastal residents, encountering bioluminescent waves often becomes a transformative experience. Those who witness these displays frequently describe feelings of profound connection to the natural world and a renewed sense of wonder. In an age of digital screens and virtual experiences, the real-world magic of watching the ocean light up with living blue fire offers a powerful reminder of nature's capacity to inspire and amaze. To maximize your chances of witnessing this phenomenon, timing is everything. Visit known bioluminescent hotspots during their peak seasons and plan your beach walks for the darkest nights around the new moon. Arrive after sunset and allow your eyes to adjust fully to the darkness. Avoid using flashlights or phone screens, which diminish your night vision. The displays typically appear most vibrant between midnight and 4 a.m., when plankton have had maximum exposure to sunlight during the day, which they use to recharge their bioluminescent capacity. Unfortunately, these magical displays face various threats in the modern world. Light pollution from coastal development diminishes the visibility of bioluminescence and may disrupt the natural cycles of the organisms that produce it. Chemical runoff, changing ocean temperatures, and acidification can alter the delicate balance of marine ecosystems that support healthy dinoflagellate populations. Some of the world's most famous bioluminescent bays have experienced concerning declines in brightness in recent years, prompting conservation efforts to protect these natural wonders. Despite these challenges, bioluminescent waves continue to illuminate coastlines around the world, from the warm waters of the Caribbean and Southeast Asia to the temperate shores of California, Australia, and the British Isles. Each location offers its own variation of this phenomenon, influenced by local species, oceanographic conditions, and seasonal patterns. The next time you find yourself on a beach at night, particularly after a warm day when the water appears reddish or brownish, indicating potential algal blooms, take a moment to look closely at the breaking waves. What might initially appear as ordinary white surf may reveal itself as something far more extraordinary. Living light produced by billions of microscopic organisms that have evolved one of nature's most enchanting adaptations. Splash your hand through the water, walk along the wet sand, or wade into the gentle surf, and you might just witness firsthand the ocean's most magical light show, a reminder that some of the sea's greatest wonders are created by its smallest inhabitants. Now, let's explore an ancient underwater structure that challenges our understanding of history. Story 26. Yonaguni Monument. Lost civilization or natural wonder. From the living light of bioluminescent waves, we now descend to the mysterious underwater structures off the coast of Japan that have sparked intense debate among archaeologists, geologists, and ancient civilization enthusiasts. The Yonaguni Monument, discovered in 1987 by dive tour operator Kihachiro Aratake, appears to be a massive stone structure with terraces, platforms, and what some believe are carved steps and columns, all submerged 100 feet beneath the East China Sea. To its advocates, the monument represents evidence of an advanced prehistoric civilization that once inhabited the region during the last ice age, when sea levels were much lower. To skeptics, it's merely an unusual but natural geological formation, shaped by millions of years of ocean currents and seismic activity. Is the Yonaguni Monument Japan's Atlantis, concrete evidence of a sophisticated maritime culture lost to rising seas 10,000 years ago? Or is it an extraordinary example of how natural processes can create formations that appear deceptively artificial to the human eye? Let's dive into one of archaeology's most contentious underwater mysteries. The waters off Yonaguni Island, the westernmost inhabited island of Japan, are known for their crystal clarity and diverse marine life. Located near Taiwan in the East China Sea, the island attracts divers from around the world who come to swim with hammerhead sharks and explore its vibrant coral reefs. But in 1987, local dive instructor Kihachiro Aratake discovered something far more enigmatic than marine wildlife while scouting for new dive spots: massive underwater structures that seem too regular, too geometric to be natural formations. What Aratake found was a series of massive stone terraces, platforms, and straight walls submerged about 100 feet below the surface. The main structure, now known as the Yonaguni Monument, or Japan's underwater pyramid, stretches for over 165 feet along the ocean floor with numerous right angles, parallel faces, and what appear to be carved steps, columns, and channels. One section bears an uncanny resemblance to a human face, while another has been dubbed the turtle due to its animal-like shape when viewed from certain angles. News of the discovery quickly spread through Japan and eventually reached international archaeological circles, sparking immediate controversy that continues to this day. At the center of the debate are two fundamental questions. Is the Yonaguni Monument natural or artificial? And if it's artificial, what does that imply about prehistoric human civilization? The most prominent advocate for the artificial origin theory is Professor Masaaki Kimura, a marine geologist from the University of the Ryukyus, who has studied the monument for over 2 decades. After numerous dives and extensive analysis, Kimura believes that the structures are at least partially man-made, representing the remains of a prehistoric city that existed when the area was above sea level during the last ice age, approximately 10,000 years ago. Kimura points to several features that he considers evidence of human intervention: perfectly straight edges and 90-degree angles uncommon in natural formations, what appear to be drainage channels, terraces, and a quarry, 2 holes that might have held supporting posts, and stone tools allegedly found at the site. He has also identified what he believes are carved symbols or characters on some surfaces. According to Kimura's theory, the monument was constructed by an advanced culture that occupied the region when sea levels were about 130 feet lower than today. This civilization would have thrived during the late Pleistocene era, only to be gradually submerged as the massive ice sheets covering much of the northern hemisphere melted, and sea levels rose dramatically between 14,000 and 10,000 years ago. If correct, this would revolutionize our understanding of prehistoric human development. The currently accepted archaeological timeline places the emergence of complex stoneworking civilizations around 5,000 years ago in Mesopotamia and Egypt. A sophisticated culture, capable of monumental stone architecture, existing 10,000 years ago, would predate these civilizations by 5 millennia and force a radical reconsideration of human history. The implications are so profound that many archaeologists and geologists approach the Yonaguni Monument with extreme skepticism. The most prominent critic is Boston University geologist Robert Schoch, who has extensively studied other controversial ancient sites like the Sphinx in Egypt. After diving at Yonaguni and examining the structures firsthand, Schoch concluded that they are the result of natural processes with some human modification. Schoch and other skeptics point out that the Yonaguni region is geologically active, with frequent earthquakes that can split rock along straight fracture lines. The monument is composed primarily of sandstone, which naturally forms in layers and can break along remarkably straight lines when subjected to tectonic forces. Similar natural formations with geometric patterns can be found around the world, from the Giant's Causeway in Ireland to the Pancake Rocks in New Zealand. Critics also note the absence of unambiguous artifacts like pottery, construction tools, or human remains that would typically be associated with an ancient settlement. The tools identified by Kimura, they argue, are simply natural stones that coincidentally resemble human implements. Furthermore, the carved symbols could be explained as natural erosion patterns or bioerosion created by marine organisms. Perhaps most significantly, if the Yonaguni monument were truly the work of an advanced civilization 10,000 years ago, it would stand in complete isolation from the archaeological record. No other sites from this period demonstrate comparable architectural sophistication or stoneworking technology. The earliest known megalithic structures date from thousands of years later and show a clear developmental progression absent from the supposedly much older Yonaguni site. Adding another layer to the debate is the complex cultural and political context surrounding the monument. The discovery has become a source of national pride for many Japanese, particularly those interested in the controversial theory that Japanese civilization has much older and more independent origins than conventionally believed. Some proponents connect the site to legends of Mu or Lemuria, hypothetical lost continents similar to Atlantis that supposedly existed in the Pacific. This cultural significance has sometimes complicated objective assessment of the site, with nationalist sentiments occasionally influencing interpretations. Similar dynamics have affected other underwater archaeological controversies, such as claims about structures off the coast of Cuba or in the Bahamas that some interpret as remnants of lost civilizations. A third perspective has emerged in recent years, that the Yonaguni monument represents a combination of natural formation and human modification. This middle ground theory suggests that prehistoric people may have recognized the site's unusual natural features and enhanced them for ceremonial or practical purposes, similar to how many ancient cultures incorporated natural rock formations into their sacred sites. Dr. John Anthony West, an independent Egyptologist, has proposed that the geology is so perfectly suited to human modification that it would have been almost criminal of the ancient inhabitants not to enhance it. Under this view, the straight edges and terraced appearance would be primarily natural, but certain features might represent human embellishment of a formation that already resembled an artificial structure. Complicating assessment of the site is its underwater location. Submerged archaeological investigation is inherently more challenging than land-based work, with limited dive times, shifting visibility conditions, and the difficulty of conducting precise measurements and excavations underwater. The monument's depth of approximately 100 feet limits dive times and requires specialized equipment, making comprehensive documentation difficult. The marine environment itself has also altered the site over millennia. Encrusting organisms, erosion from currents and storm activity, and the accumulation of sediment have all modified the monument's appearance since its submergence. Distinguishing between natural marine weathering and intentional human carving becomes increasingly problematic the longer a structure remains underwater. In recent years, advanced underwater mapping technologies have provided more detailed visualizations of the monument. Photogrammetry, three-dimensional modeling, and high-resolution sonar have created comprehensive digital recreations that allow researchers to study the site without the limitations of physical diving. These techniques have revealed additional details about the structure's geometry and proportions, but have not resolved the fundamental debate about its origin. One significant fact often overlooked in discussions about Yonaguni is that the region does contain confirmed ancient human settlements, though much more recent than those proposed by Kimura. Archaeological evidence indicates that Yonaguni and surrounding islands were inhabited at least 2,500 years ago, with distinctive cultures developing in the Ryukyu archipelago. These populations might have interacted with natural formations at Yonaguni before they were submerged, possibly leaving trace modifications that complicate modern interpretation. The geological history of the region provides important context for evaluating the monument. During the last ice age, Yonaguni was connected to Taiwan and mainland China as part of a larger landmass known as Sundaland. When sea levels rose at the end of the Pleistocene, vast coastal plains were submerged, potentially covering any settlements that existed in these now underwater regions. This reality has fueled speculation about lost civilizations not just at Yonaguni, but throughout Southeast Asia. The debate about the Yonaguni monument reflects broader tensions within archaeology about how to interpret ambiguous evidence and where to draw the line between natural and artificial structures. Similar controversies have erupted around other underwater sites, including the alleged Roads of Bimini in the Bahamas and various claimed structures in the Mediterranean and Caribbean. These debates often pit mainstream academic archaeologists, who demand rigorous evidence before accepting claims that would fundamentally revise established chronologies, against independent researchers more willing to entertain alternative interpretations of history. The latter frequently accuse academia of institutional bias and resistance to paradigm shifts, while academic archaeologists criticize what they see as speculation unsupported by systematic evidence. For visitors who dive at Yonaguni today, the monument remains an awe-inspiring sight regardless of its origin. Swimming alongside massive stone terraces that seem to lead up to a giant platform, with perfectly straight edges disappearing into the blue distance, creates an undeniable impression of an architectural space. The play of light and shadow across the stone surfaces, the schools of fish darting between the columns, and the monumental scale of the formation combine to create an almost mystical experience. Many divers report a strong intuitive sense that they are exploring something built rather than naturally formed, though psychologists note that humans are predisposed to recognize patterns and impose order on random or natural phenomena. This tendency to see intentional design in natural formations, known as pareidolia, may contribute to perceptions of artificiality at sites like Yonaguni. Despite decades of research, the true nature of the Yonaguni monument remains unresolved. The preponderance of geological evidence suggests a primarily natural origin, with the striking geometric appearances resulting from the natural properties of bedded sandstone subjected to tectonic forces, erosion, and the region's distinctive wave action. Yet the possibility of some degree of human modification cannot be conclusively dismissed. What makes the Yonaguni monument so compelling is not just the specific debate about its origin, but the broader questions it raises about how we interpret the physical remnants of the past. How do we distinguish between natural processes and human intervention? How should we evaluate evidence that doesn't fit neatly into established historical narratives? And perhaps most intriguingly, what might lie undiscovered on the vast submerged continental shelves that were habitable during the last ice age? As sea levels continue to rise due to climate change, similar questions will become increasingly relevant to archaeological investigation. Coastal sites currently being studied may themselves become underwater mysteries for future generations, joining Yonaguni as enigmatic windows into humanity's complex relationship with the ever-changing boundary between land and sea. Whether entirely natural, completely artificial, or something in between, the Yonaguni monument stands as a testament to the ocean's capacity to preserve and transform, to reveal and conceal. Like many of the greatest ocean mysteries, it reminds us that beneath the waves lie not just questions about the sea itself, but about our own human story, and the countless chapters that may have been submerged by rising waters and the relentless passage of time. Story 27, SS Ourang Medan, the Ship of the Dead. From the submerged stone enigma of the Yonaguni monument, we now sail into perhaps the most chilling maritime mystery of the 20th century, the case of the SS Ourang Medan. In June 1947, multiple ships in the Strait of Malacca reportedly received a chilling distress call. All officers, including captain, are dead, lying in chart room and bridge. Possibly whole crew dead. After a brief silence, two final words came through. I die. When rescuers boarded the Dutch freighter hours later, they allegedly found the entire crew dead with faces frozen in expressions of absolute terror, eyes open, mouths agape, and arms outstretched as if warding off an invisible attacker. No signs of injury were visible on any of the bodies. Before investigators could determine the cause of death, the ship mysteriously caught fire and exploded, sinking with all evidence to the bottom of the ocean. Was the Ourang Medan the victim of pirates, poisonous gas, or something far more sinister? And more fundamentally, did this ghost ship even exist, or is it the most elaborate sea hoax ever perpetrated? The tale of the SS Ourang Medan begins not with certainty, but with whispers and fragmented accounts. Unlike many maritime disasters that leave behind official records, photographs, and survivor testimonies, the story of this ghost ship emerges primarily from secondhand sources and scattered references that have proven frustratingly difficult to verify. According to the most widely circulated version of events, in June 1947, though some accounts place it in February 1948, several ships navigating the Strait of Malacca, the narrow shipping lane between Sumatra and Malaysia, received a disturbing SOS message in Morse code. All officers, including captain, are dead lying in chart room and bridge. possibly whole crew dead. This was followed by indecipherable Morse code, and then the final words, "I die." The message was reportedly triangulated to a Dutch merchant vessel identified as the SS Ourang Medan. The American ship Silver Star, said to be the closest vessel to the distress call, diverted its course to offer assistance, locating the silent Ourang Medan adrift at sea. What the rescue party allegedly discovered aboard the Medan has become the stuff of maritime nightmares. Throughout the ship, on the bridge, in the chart room, on deck, and in the boiler room, lay the bodies of the crew, all dead. Even the ship's dog was reportedly found frozen in mid-growl. Most disturbing were the expressions on the faces of the deceased, eyes wide open in terror, mouths agape as if screaming, and arms outstretched as if warding off an invisible assailant. Despite the tropical heat, their bodies had reportedly already begun to stiffen with rigor mortis. Yet despite these horrifying postures, no visible signs of injury or trauma could be found on any of the bodies. There was no evidence of struggle, no wounds, no blood. The ship itself showed no damage or signs of attack. Whatever had killed the crew had left no obvious trace of its method. Before the bodies could be examined more thoroughly, or the ship searched completely, rescuers reportedly noticed smoke rising from the cargo hold. The captain of the Silver Star ordered his men to abandon the Ourang Medan. They had barely made it back to their own vessel when the Ourang Medan exploded with such force that it lifted out of the water before quickly sinking beneath the waves, taking with it all evidence of what had transpired and the bodies of its unfortunate crew. This dramatic tale has captivated maritime enthusiasts for decades, spawning theories ranging from the plausible to the supernatural. But before examining these explanations, we must confront a more fundamental question. Did the SS Ourang Medan actually exist? Skeptics have pointed to several troubling inconsistencies in the historical record. No official registration records for a vessel named Ourang Medan have been conclusively identified. The Silver Star, the American ship that supposedly responded to the distress call, did exist, but shipping records don't confirm its presence in the Strait of Malacca during the period in question. Furthermore, no contemporary newspapers appear to have reported the incident when it allegedly occurred. The first published account of the Ourang Medan incident didn't appear until May 1952, when the story was mentioned in the Proceedings of the Merchant Marine Council, a publication of the United States Coast Guard. This was followed by more detailed accounts in Dutch, Indonesian newspapers in 1954, and later in a 1955 book called Das Totenschiff in der Südsee, meaning the death ship in the South Seas, by German author Otto Milky. These belated and somewhat contradictory accounts, combined with the lack of official records, have led many researchers to classify the Ourang Medan as a maritime legend rather than a documented historical event. Yet others point to the specific details in these accounts, particularly the later Dutch-Indonesian newspaper reports, as evidence that something real may underlie the story, even if details were embellished or confused over time. For those who accept that some version of the incident occurred, the central mystery remains. What could have killed an entire ship's crew without leaving any visible injuries? One of the most plausible explanations involves hazardous cargo. In the post-World War II era, ships sometimes transported dangerous materials without proper documentation, either for legitimate military purposes or as part of black market operations. The Strait of Malacca, then as now, was a busy shipping lane connecting the Indian and Pacific Oceans, making it a strategic route for all manner of cargo. Specifically, some researchers have suggested the Ourang Medan might have been carrying improperly stored chemical weapons or nerve agents being smuggled from Japanese military installations after the war. Materials like potassium cyanide or even chemical warfare agents like sarin gas could, under certain conditions, leak from their containers and rapidly kill everyone aboard. The ship's eventual explosion and sinking could have resulted from these same chemicals reacting with seawater or creating combustible gas mixtures. This theory is particularly compelling, given the historical context. After World War II, there was significant covert activity involving the movement of Japanese and German military technology and weapons, with both Allied and Soviet forces seeking to acquire enemy developments. The hasty disposal or transportation of chemical weapons, often with minimal safety precautions, has been documented in other contexts during this period. A variation on this theory suggests the ship might have been carrying improperly stored conventional cargo that produced deadly fumes. Chemicals like methane, hydrogen cyanide, or carbon monoxide could have been produced by decomposing organic materials in the hold or by poorly ventilated refrigeration systems. In the enclosed space of a ship, these gases could rapidly reach lethal concentrations. The facial expressions and postures of the dead crew members, as described in the accounts, are consistent with certain types of chemical poisoning, particularly those affecting the nervous system or causing asphyxiation. The sudden fire and explosion that reportedly consumed the ship could also be explained by the ignition of accumulated gases. Natural phenomena offer another set of potential explanations. One theory involves underwater seismic activity, releasing pockets of methane or carbon dioxide from the seabed. If a large bubble of such gas were to rise beneath a ship and envelop it, the crew could be asphyxiated within minutes. This phenomenon, sometimes called the bubble theory, has been proposed as an explanation for some ships that have disappeared in the Bermuda Triangle and other areas. The Strait of Malacca does lie in a seismically active region, making this scenario theoretically possible, though such massive gas releases are extremely rare and would typically affect multiple vessels in an area rather than a single ship. Another natural explanation involves extreme weather phenomena. Ball lightning, a rare and poorly understood electrical phenomenon, has been known to enter ships and has been cited as a potential explanation for some maritime mysteries. If a powerful electrical discharge entered the Ourang Medan, it could potentially have killed crew members without leaving obvious external injuries. For those inclined toward more exotic explanations, the Ourang Medan has become associated with theories involving paranormal phenomena, extraterrestrial encounters, or even experiments with electromagnetic weapons. The terrified expressions on the dead crew members' faces, the lack of visible injuries, and the mysterious complete destruction of the vessel have all fueled speculation about forces beyond conventional understanding. Some have suggested the crew might have experienced a mass hallucination or psychosis, perhaps induced by toxic fungi growing on the ship's food supplies or by exposure to chemical agents that affected their neurological functions before killing them. This could potentially explain reports of crew members dying in postures suggesting extreme terror or defensive reactions against invisible threats. The most skeptical analysts suggest that the entire story is a fabrication, either a sailor's tall tale that grew with each retelling, or perhaps a deliberate hoax created for unknown purposes. Maritime folklore is rich with ghost ship stories, from the Flying Dutchman to the Mary Celeste, reflecting the isolation and dangers faced by those who travel the seas. The Ourang Medan may simply be a modern addition to this tradition, albeit one with unusually specific details. If the story was fabricated, the question becomes, by whom and why? Some have speculated that the tale might have originated as a cover story for covert Cold War operations, or as a cautionary tale deliberately spread to discourage investigation of certain shipping activities in the region. Without primary sources or official documentation, these theories remain speculative. What makes the Ourang Medan case so enduringly fascinating is its position at the intersection of verifiable maritime hazards and seemingly inexplicable circumstances. The specific details, the terrified expressions, the outstretched arms, the rapid onset of rigor mortis, the mysterious explosion, create a scenario that seems simultaneously plausible and impossible. For sailors, the story serves as a chilling reminder of the many dangers that can strike at sea, from hazardous cargo to deadly gases to the unpredictable forces of nature. For paranormal enthusiasts, it represents one of the most compelling modern ghost ship tales, with enough specific details to suggest authenticity but enough mystery to leave room for supernatural interpretations. Whether the SS Ourang Medan was a real vessel that met a tragic and mysterious end, a composite story based on multiple incidents, or a pure fabrication, its tale has secured a permanent place in maritime lore. The image of a ship, drifting silently with its crew dead at their posts, faces frozen in expressions of unspeakable horror, continues to haunt our collective imagination of the sea's darkest mysteries. Like the mythical Flying Dutchman, doomed to sail the seas forever, the Ourang Medan continues its voyage through our cultural consciousness, a reminder that for all our technological advancement and scientific understanding, the vast oceans still harbor mysteries that defy easy explanation, and perhaps always will. Story 28. SS Baychimo, the Arctic Ghost Ship. From the fiery depths of submarine volcanoes, we now sail into frigid Arctic waters, where one of history's most remarkable ghost ships drifted alone for decades. The SS Baychimo, a 1,300-ton cargo steamer, was abandoned by her crew in 1931 after becoming trapped in Arctic ice off the coast of Alaska. They expected the ship to be crushed and sink within days. Instead, the Baychimo broke free and began a ghostly solo voyage that would last for nearly 4 decades. Sighted more than a dozen times between 1931 and 1969, this incredible ghost ship survived some of the world's most treacherous waters without a crew, appearing and disappearing like a maritime phantom. Several salvage attempts failed when the vessel seemed to vanish just as recovery teams approached. Was the Baychimo simply the beneficiary of extraordinary luck, or was something more mysterious at work in the icy waters of the Arctic? This is the remarkable tale of the ghost ship that refused to die. The saga of the SS Baychimo begins in 1914 when she was built in Sweden for the Hamburg America line and christened as the Ångermanelfen. She was a sturdy 1,322-ton cargo steamer, 230 feet long, and designed specifically for operation in harsh northern climates, with a reinforced hull to help navigate the ice-choked waters she would encounter. After World War I, the vessel was transferred to Britain as war reparations and acquired by the Hudson's Bay Company, which renamed her Baychimo and put her to work in the Arctic. For the next decade, the Baychimo served dutifully as a trading vessel along Alaska's northern coast, carrying supplies to remote settlements and returning with valuable furs from indigenous trappers. This was challenging but profitable work in the early 20th century, as the isolated communities of the Arctic relied heavily on such ships for their connection to the outside world. On October 1st, 1931, the Baychimo was on her annual end-of-season voyage, attempting to make a final delivery before the winter ice closed in. The ship was near Barrow, Alaska, now known as Utqiagvik, when disaster struck. Unseasonably early ice formation trapped the vessel. The 14-man crew abandoned ship and made their way across the ice to Barrow, where they established a temporary camp to wait out the situation, hoping for a break in the ice that would free their vessel. Their patience seemed rewarded on October 15th when a brief respite in the weather opened a lead in the ice. The Baychimo was free, and the crew reboarded, only to be trapped again within days as the ice closed in once more. This time, Captain Sidney Cornwell made a more significant decision. He ordered the retrieval of the most valuable cargo, and the crew established a more permanent camp on shore. The captain and 14 crew members settled in to wait out the winter, assuming that the ship would either be crushed by the ice or could be retrieved in the spring thaw. But a powerful blizzard struck on November 24th, 1931, with winds so severe that visibility dropped to zero for several days. When the storm finally cleared on November 26th, the men looked out to where their ship had been trapped in ice, only to discover that the Baychimo was gone. Assuming the vessel had sunk, they prepared to eventually make their way south. Just days later, however, a native Inupiat hunter arrived at their camp with surprising news. The Baychimo had not sunk, but was floating freely in ice about 45 miles away. The ship had somehow broken free during the blizzard and drifted away. Captain Cornwell and some of his crew trekked to the reported location, and indeed found their vessel, damaged but afloat. After inspecting the ship, Cornwell made a fateful decision that would enter the Baychimo into maritime legend. He deemed the vessel too damaged to survive the winter and too risky to attempt boarding for longer than it took to remove additional cargo. The Hudson's Bay Company apparently agreed, arranging for the captain and most of the crew to return to their homes. A skeleton crew remained in Barrow for the winter to guard the remaining cargo, but the Baychimo herself was abandoned to her fate. That fate would prove far more enduring than anyone expected. Rather than sinking beneath the ice, the Baychimo began her career as a legendary ghost ship, drifting alone through some of the world's most treacherous waters. The first post-abandonment sighting came just weeks later, when the Baychimo was spotted drifting about 300 miles from where she had been left. Over the next several decades, the ship would be sighted at least a dozen more times in various locations around the Arctic Ocean and Beaufort Sea, becoming one of the most famous ghost ships in maritime history. In March 1932, a party of Inupiat seal hunters encountered the Baychimo, trapped in ice, and actually boarded her, finding the ghostly interior exactly as the crew had left it months earlier, personal belongings still in place. Later that same year, a trading schooner encountered the vessel drifting freely and attempted to salvage her, but weather conditions made this impossible. In 1933, the Baychimo was spotted again, this time by a group of explorers who managed to board her and retrieved some of the valuable furs still in her hold. Captain Cornwell himself attempted to relocate and salvage his former vessel that same year, but could not find her among the vast Arctic ice fields. Throughout the 1930s and 1940s, the Baychimo continued to appear and disappear, sighted by various ships, coastal observers, and even an occasional aircraft. Each time, she seemed to vanish before any serious salvage attempt could be organized, earning her the nickname, the Ghost Ship of the Arctic. In 1939, a group of native Alaskans boarded her, taking shelter inside her hull during a storm. They reported that the interior was increasingly ice-filled but structurally intact, despite having endured 8 years of unmanned navigation through ice-filled waters. Perhaps the most tantalizing encounter came in 1962, more than 3 decades after her abandonment, when a group of Inupiat spotted the Baychimo frozen in an ice floe. They boarded the vessel and explored her ice-encrusted interior, describing the eerie sensation of walking through the frozen corridors of a ship that had been sailing the Arctic without a crew for 31 years. The last confirmed sighting of the Baychimo came in 1969, 38 years after she was abandoned. She was spotted floating off Alaska's northwest coast, but disappeared again before she could be approached. The intervening decades have seen no verified sightings of the vessel, leading most experts to conclude that the Baychimo finally succumbed to the elements, likely sinking in deep water, or being crushed between ice floes in some remote corner of the Arctic. The Baychimo's extraordinary survival for nearly 4 decades without a crew raises fascinating questions about the vessel and the unique environment of the Arctic. How did a steam-powered cargo ship, abandoned and expected to sink within days, manage to navigate the ice-choked Arctic waters for nearly 40 years without human guidance? Several factors likely contributed to this remarkable feat of nautical endurance. The Baychimo was specifically designed for Arctic service, with a reinforced hull that could withstand significant ice pressure. Her sturdy construction, typical of vessels built in the early 20th century, gave her natural resilience against the elements. The Arctic environment itself, while harsh, also offered some protective factors. During winter months, the ship would often become frozen in pack ice, which, rather than crushing her as feared, may have actually provided a stable platform that prevented structural stress from waves and storms. During summer thaws, the natural currents and wind patterns of the Arctic likely propelled the vessel through relatively open waters. Modern climate scientists and oceanographers studying the Baychimo case have suggested that the vessel was caught in the Beaufort Gyre, a major circular ocean current in the Arctic that could have carried the ship in a slow, meandering pattern around the Beaufort Sea for decades. This would explain the seemingly random appearances across a wide geographic area and the ship's ability to remain within the Arctic region rather than drifting into the Pacific or Atlantic. The Baychimo's ghost ship status has inspired numerous legends and supernatural interpretations. Some native Alaskan traditions came to view the vessel as possessed by spirits, explaining its ability to appear and disappear at will. Sailors in the region sometimes reported seeing lights aboard the abandoned vessel at night, though these accounts are difficult to verify and may be examples of the rich maritime folklore that often surrounds ghost ships. More practical explanations for the Baychimo's longevity focus on her construction and luck. Steam-powered vessels of her era were built with thick steel plates and numerous watertight compartments. Even with moderate damage, many compartments could flood while leaving the ship afloat. The Baychimo's cargo of furs may have also played a role in her buoyancy, as the natural oils in untreated animal pelts provide some water resistance. The Baychimo has achieved legendary status in maritime history, joining the ranks of famous ghost ships like the Mary Celeste and the Flying Dutchman. Unlike many ghost ship tales, however, the Baychimo's story is thoroughly documented through multiple credible sightings over decades, making her one of the most well-attested ghost ships in nautical history. The vessel's legacy extends beyond mere maritime curiosity. The Baychimo case has provided valuable data for researchers studying Arctic ice patterns, ocean currents, and the durability of vessels in extreme conditions. Naval architects have studied the accounts of her survival to improve modern ship designs for polar operations. For the Inupiat and other native Alaskan communities of the North Slope, the Baychimo became integrated into local oral traditions, a strange visitor from the outside world that became part of their landscape. Stories of encountering and occasionally sheltering within the ghost ship have been passed down through generations. The mystery of the Baychimo's final fate remains unsolved. No wreckage has ever been conclusively identified as belonging to the vessel. The most likely scenario is that after nearly 4 decades of unmanned navigation, the accumulation of ice and structural fatigue finally reached a critical point, and the ship sank in deep water. Alternative theories suggest she may have run aground on a remote shoreline or been crushed between ice floes in an unwitnessed area. Modern technology has raised the possibility of locating the Baychimo if she still exists. Autonomous underwater vehicles equipped with advanced sonar can now map large sections of the Arctic seafloor, potentially revealing the final resting place of this legendary vessel. Several organizations have expressed interest in mounting expeditions to search for the wreck, though the vast area of the potential search zone makes this a daunting prospect. The story of the SS Baychimo represents a unique intersection of natural resilience, maritime mystery, and human fascination with the inexplicable. That a vessel abandoned to the elements could survive for nearly 4 decades in one of Earth's harshest environments, appearing and disappearing like a phantom, challenges our understanding of ships in the sea. Perhaps the most profound aspect of the Baychimo tale is what it tells us about our relationship with the vast wilderness of the Arctic. In this remote region, where human presence has always been tenuous and temporary, the ghost ship Baychimo became a symbol of both human vulnerability and the surprising durability of our creations. Long after her crew had returned to their homes, and even after many had lived full lives and passed away, their ship continued to sail the Arctic waters alone, a steel island drifting through the ice, carrying the echoes of human presence through a wilderness where we remain, at best, temporary visitors. The SS Baychimo, last seen in 1969, may still exist somewhere in the depths of the Arctic Ocean, her hull now a marine habitat, her cargo holds filled with silt, her ghost ship days finally ended. Or perhaps, as some romantics prefer to believe, she still drifts with the ice in some remote corner of the Arctic, waiting to be glimpsed once more, the ship that refused to die, sailing ever onward through the frozen seas. Now, let us explore one of nature's most spectacular oceanic phenomena, where 2 distinct seas meet but refuse to fully blend. Story 29. Convergence of Baltic and North Seas. The waters that won't mix. From the ghostly wanderings of the SS Baychimo through Arctic waters, we now turn to one of the most visually striking oceanographic phenomena in the world, the convergence of the Baltic and North Seas. Off the coast of Denmark at the Skagen Peninsula, these 2 massive bodies of water meet in a spectacular display, where a clear, visible line forms on the ocean's surface. On one side flow the darker, saltier waters of the North Sea, on the other the lighter, less saline waters of the Baltic. Rather than immediately blending, these distinct water masses maintain their separation, creating what appears to be a maritime border that can be crossed by boat, yet remains stubbornly persistent. What causes this extraordinary phenomenon, where you can literally sail your boat across 2 seas simultaneously? And what does this visible boundary tell us about the hidden layers and currents that shape our oceans? Let's explore this remarkable convergent zone, where the seas meet but refuse to mix. At the northernmost tip of Denmark, where the Skagen Peninsula juts into the sea like a crooked finger, visitors witness one of the most visually dramatic oceanographic phenomena on Earth. Here, the dark blue waters of the North Sea collide with the lighter, greener waters of the Baltic Sea, creating a distinct line that stretches across the horizon. This isn't an optical illusion or a trick of the light. It's a visible manifestation of fundamental differences between 2 major bodies of water that refuse to fully blend. To understand this remarkable boundary, we must first appreciate the distinct characteristics of the seas involved. The North Sea is essentially an extension of the Atlantic Ocean, with a relatively high salt content, about 35 parts per thousand, consistent with most ocean waters. It's subject to powerful tidal forces, and shares the chemical and physical properties of the greater Atlantic. The Baltic Sea, in contrast, is a semi-enclosed body of water that receives enormous freshwater input from numerous rivers draining a vast watershed across northern Europe. This influx of fresh water dilutes the Baltic's salinity to mere 8 parts per thousand, making it brackish rather than truly marine. The Baltic also contains different suspended sediments and organic matter than the North Sea, contributing to its distinctive color. When these fundamentally different water masses meet at Skagen, they don't immediately merge despite their physical contact. Instead, a phenomenon called a halocline forms, a sharp boundary layer between waters of different salinities. The saltier North Sea water, being denser, attempts to flow beneath the lighter Baltic water, while the fresher Baltic water tends to flow over the top of the North Sea water. This creates a sloping underwater boundary between the two water masses. What makes this convergence particularly visible is the combination of density differences, color variations, and the distinctive way light interacts with the two water bodies. The North Sea typically appears darker blue, while the Baltic Sea takes on a more greenish-gray hue due to differences in sediment, plankton content, and light refraction through water of different densities. For visitors who take boat tours to witness this phenomenon, the experience is remarkable. Vessels can literally straddle the boundary, with their port side in one sea and their starboard side in another. Passengers can dip one hand into each sea simultaneously, feeling the slight temperature difference between the warmer Baltic and cooler North Sea waters. Some even bring containers to collect samples from each side, visibly demonstrating the color and clarity differences when held side by side. Beyond its visual spectacle, this convergence zone creates a unique and complex marine ecosystem. The boundary between these water masses acts as a biological front, concentrating nutrients and creating feeding opportunities for marine life. Fish that can tolerate the transition between different salinity regimes often gather in these convergence areas, taking advantage of the accumulated food resources. This, in turn, attracts seabirds and marine mammals, making the area a hotspot for biodiversity. Fishermen have long known that these boundary zones are productive fishing grounds. The concentration of nutrients and plankton leads to aggregations of herring, mackerel, and cod, particularly during certain seasons when the boundary becomes more pronounced. Historical fishing villages along the Skagen coast developed specifically to exploit this natural abundance. The convergence doesn't maintain a fixed position, but shifts with weather conditions, seasonal changes, and longer-term climate fluctuations. Strong, sustained winds can push the surface waters in different directions, sometimes making the boundary more pronounced and at other times causing it to become more diffuse. During winter storms, when mixing is most intense, the visible line may temporarily disappear, only to reform when calmer conditions return. This dynamic nature of the boundary adds another layer of complexity to the phenomenon. Oceanographers monitoring the convergence zone have documented how it shifts position by several kilometers depending on prevailing winds and current strengths. During periods of strong westerly winds, the North Sea water pushes farther into the Baltic, while during easterly wind periods, the Baltic waters extend their reach westward. The meeting of these seas represents a scaled-down version of similar ocean convergence zones found throughout the world's oceans. The most famous of these is perhaps the boundary between the Atlantic and Mediterranean at the Strait of Gibraltar, where Atlantic waters flow into the Mediterranean on the surface, while saltier Mediterranean water flows outward at depth. Similar phenomena occur at the Bosphorus Strait, between the Black Sea and the Mediterranean, and at the confluence of the Amazon River with the Atlantic Ocean. What makes the Baltic North Sea convergence particularly accessible is its visibility from shore and the ease with which visitors can observe it during boat tours. Unlike many oceanographic phenomena that require specialized equipment or exist in remote locations, this remarkable boundary can be witnessed by anyone visiting the Skagen Peninsula. The scientific significance of this convergence extends beyond its visual appeal. The boundary serves as a natural laboratory for studying how water masses of different properties interact, mix, and maintain separation. Research vessels equipped with sophisticated instruments regularly sample along transects crossing the boundary, measuring everything from temperature and salinity profiles to nutrient concentrations and microscopic marine life. These studies have revealed complex patterns of exchange between the water masses. Rather than a simple surface phenomenon, the convergence creates a three-dimensional structure extending from surface to seafloor. At different depths, fingers of North Sea water intrude into the Baltic, while Baltic water masses extend into the North Sea, creating a complex interleaving pattern invisible from the surface. The exchange of water between these seas has important implications for marine ecology throughout the region. Baltic fish species that spawn in saltier waters must navigate these transitional zones, timing their migrations to coincide with favorable conditions. Pollutants and nutrients introduced into either sea gradually cross this boundary, affecting water quality and ecosystem health across the region. Climate change is adding another dimension to this ancient boundary. As global warming alters precipitation patterns across northern Europe, the freshwater input to the Baltic is changing. Some climate models predict increased rainfall over the Baltic watershed, which would lower the sea's already minimal salinity and potentially strengthen the contrast at the convergence zone. Other models suggest changing wind patterns could alter the dynamics of water exchange between the seas. Rising sea levels also threaten to reshape this oceanographic feature. As oceans rise, the bathymetry, or underwater topography, that helps maintain the separation between water masses will be altered, potentially changing where and how distinctly the boundary forms. For mariners throughout history, this convergence zone has presented both opportunity and hazard. The meeting of different water masses creates complex wave patterns and challenging currents that small vessels must navigate carefully. Historical accounts from sailing ships describe the distinctive ruffled water, or boiling seas, where the waters meet, particularly during periods of strong winds when steep, confused wave patterns can form. Despite these challenges, the convergence has also served as a navigational landmark for centuries. Before modern GPS and electronic charts, sailors used the visible boundary as confirmation of their position when approaching the treacherous northern tip of Denmark. Even today, the boundary serves as a readily identifiable reference point for fishing vessels and pleasure craft operating in the region. The cultural significance of this natural phenomenon runs deep in local traditions and identity. The town of Skagen itself has been shaped by its position at this maritime crossroads. In the late 19th century, a colony of Scandinavian artists, known as the Skagen painters, were drawn to the area specifically for its unique quality of light, a characteristic directly influenced by the meeting of the seas and how sunlight interacts differently with the two water masses. These painters, including P.S. Krøyer, Michael Angscher, and Anna Angscher, created works that celebrated the distinctive atmosphere of Skagen, with its blue-tinted light reflecting off the converging waters. Their paintings often depicted the local fishing community against the backdrop of the dual seas, capturing both the natural phenomenon and human relationship with this unusual environment. Local folklore contains numerous tales about the convergence, from legends of underwater kingdoms meeting at the boundary to stories of ships that could sail into liminal spaces between worlds at the convergence point. While these tales belong to mythology rather than oceanography, they reflect the profound impression this visible boundary between waters has made on human imagination throughout history. Today, tourism centered around the convergence has become a significant economic driver for the region. Boat tours, specifically marketed as Two Seas tours, take visitors to witness the boundary, with captains skilled at finding the most visible sections of the convergence on any given day. Waterfront restaurants serve Two Seas platters featuring fish species from both the North and Baltic Seas, and local souvenirs often depict the distinctive meeting of waters. For scientists, the Baltic North Sea convergence represents more than a tourist attraction. It's a window into fundamental oceanographic processes that operate throughout the world's oceans. The same principles of density-driven water movement, halocline formation, and limited mixing that create this visible boundary also drive global ocean circulation patterns, like the Gulf Stream and deep water formation in polar regions. By studying this accessible convergence zone, oceanographers gain insights applicable to understanding larger-scale ocean dynamics that influence climate, marine ecosystems, and environmental change worldwide. The distinct boundary serves as a natural tracer experiment, allowing researchers to track how substances, organisms, and energy move between adjacent but distinct marine environments. The next time you see photographs of that striking line where the Baltic meets the North Sea, remember that you're looking at more than just a visually compelling oceanographic curiosity. This convergence represents a dynamic boundary between ecosystems, a living laboratory for scientific research, a cultural touchstone for local communities, and a perfect illustration of how the ocean, far from being a uniform body of water, is a complex mosaic of distinct water masses, each with its own properties and behaviors. In a world where boundaries often create division, the convergence of the Baltic and North Seas reminds us that in nature, boundaries can be zones of extraordinary productivity, beauty, and exchange, places where differences meet but aren't erased, creating something more remarkable than either could achieve alone. Story 30, Carroll A. Deering, the ghostly schooner of Diamond Shoals. From the remarkable convergence where two seas meet but refuse to mix, we now sail into one of the most baffling maritime mysteries of the 20th century, the case of the Carroll Deering. In January 1921, this five-masted commercial schooner was found hard aground on the treacherous Diamond Shoals off North Carolina, her sails set but her crew nowhere to be found. The ship showed signs of recent habitation. Food was laid out for a meal never eaten, the crew's personal belongings remained in their quarters, and the ship's log and navigation equipment were missing. What made this ghost ship particularly peculiar were reports that she had been seen behaving erratically days earlier, with an unfamiliar crew manning her decks and a person who wasn't her captain shouting orders through a megaphone. Despite an investigation involving multiple federal agencies, including the FBI, the fate of the Deering's crew remains unsolved a century later. Was it mutiny, piracy, rum runners, or something even more sinister that left this vessel crewless on one of the Atlantic's most dangerous shoals? In the early morning hours of January 31st, 1921, Coast Guardsman C.P. Brady of the Cape Hatteras station spotted a large vessel aground on Diamond Shoals, one of the most treacherous areas of the Atlantic coastline, often called the graveyard of the Atlantic. Through his binoculars, Brady could see it was a large schooner with all sails set, but strangely, no sign of activity on deck despite the perilous situation. The vessel was thoroughly stuck on the shoals, but no distress signals flew from her masts. Due to the rough sea conditions, it took 4 days before a boarding party could reach the stranded vessel. When they finally climbed aboard on February 4th, they discovered the ship was the Carroll Deering, a 255-foot 5-masted schooner built in 1919. The scene that greeted them was deeply unsettling. The ship was completely abandoned. The boarding party found the navigation equipment and ship's log missing, the crew's personal belongings still in their quarters, and food laid out in the galley as if a meal had been in preparation when the crew vanished. 2 lifeboats were missing, but otherwise, the vessel appeared largely undamaged and in good condition apart from being aground. Most puzzling, the ship's anchors were still stowed, suggesting no attempt had been made to prevent the grounding, unusual behavior for experienced sailors approaching dangerous shoals. The Carroll Deering was not an ordinary vessel. As one of the last large commercial sailing ships built in the United States, she represented the twilight of the age of sail. At 1,879 tons and stretching 255 feet, the 5-masted schooner was designed for the transatlantic trade, capable of carrying massive cargoes with a relatively small crew. She had been constructed by the G.G. Deering Company in Bath, Maine, and named after the company owner's son. For her final voyage, the Deering had departed Norfolk, Virginia, on August 26, 1920, bound for Rio de Janeiro with a cargo of coal. She was under the command of Captain William H. Merritt, accompanied by his son as first mate and a crew of 10 men. Shortly after departure, Captain Merritt fell ill, forcing the vessel to stop at the port of Lewis, Delaware, where both Merritts had to leave the ship. A new captain, W.B. Warmell, a 58-year-old veteran mariner with decades of experience, was brought aboard to continue the voyage. The Deering reached Rio without further incident, delivered her cargo, and began the return journey on December 2, 1920, now in ballast without cargo. She made a supply stop in Barbados on January 9, 1921, where Captain Warmell reportedly mentioned to the only other American captain in port that he had a troublesome crew, with the exception of the engineers and steward. What happened after the Deering left Barbados is where the mystery truly begins to unfold. On January 29, 1921, 2 days before she was discovered aground, the ship was spotted by the Cape Lookout lightship in North Carolina. The lightship keeper, Captain Jacobson, reported that a man aboard the Deering who was not Captain Warmell hailed the lightship through a megaphone. This unknown man, described as a red-haired or foreign-looking person, reported that the Deering had lost her anchors. The crew, according to Jacobson, appeared to be milling around on deck, standing in places where regular crew members would not normally be stationed. This sighting, with its suggestions of disorder aboard the vessel, would later become a crucial piece of evidence when investigators tried to piece together the Deering's final days. How had the ship managed to sail past Cape Lookout and nearly 100 miles farther up the coast with an apparently disorderly crew, only to run aground on Diamond Shoals, one of the most notoriously dangerous areas along the eastern seaboard? The discovery of the abandoned Deering triggered one of the most extensive investigations in maritime history. The case was so baffling and concerning that 5 federal departments became involved: Commerce, Treasury, justice, navy, and state. The investigation was led by the then-young FBI, with even J. Edgar Hoover taking an interest in the case. Investigators pursued multiple theories to explain the crew's disappearance. The most conventional explanation was that the crew had abandoned ship during the treacherous weather conditions that had been reported in the area. Diamond Shoals was notorious for its shifting sandbars and dangerous currents, which had claimed hundreds of vessels over the years. Perhaps the crew, realizing they were being driven onto the shoals and unable to prevent the grounding, took to the lifeboats in a desperate attempt to reach safety. However, this theory had significant flaws. Why would experienced sailors abandon an intact vessel for the much greater danger of small lifeboats in rough seas? Moreover, if they had evacuated in an orderly fashion, why was food left half-prepared in the galley? And most tellingly, why were no bodies or lifeboat wreckage ever found washing ashore, as would be expected if the lifeboats had capsized in the turbulent waters? A more sinister theory centered on mutiny. Captain Wormel's reported comments in Barbados about his troublesome crew suggested possible tensions aboard the vessel. The unusual scene observed by the Cape Lookout lightship, with an unknown man giving orders and crew members in irregular positions, could indicate that the crew had already seized control of the ship by that point. Under this theory, the mutineers might have forced Captain Wormel and any loyal crew members into lifeboats or thrown them overboard before attempting to sail the vessel themselves. Their inexperience in handling such a large schooner could have led to the grounding on Diamond Shoals, after which they escaped in the remaining lifeboats. This would explain the missing navigational equipment and logbook, which mutineers might have taken to cover their tracks. Another theory popular at the time was piracy. The early 1920s saw a significant rise in rum running and other smuggling activities due to Prohibition, which had begun in the United States in January 1920. Pirates or hijackers might have boarded the Deering, removed the crew, and attempted to sail her to a predetermined location. When the vessel ran aground, they escaped with whatever valuables they could carry, including the ship's papers. Supporting this theory were reports of other vessels that disappeared in the same general area and time frame, including the sulfur freighter SS Hewitt, which vanished with 38 men aboard after departing Portland, Maine, for Cuba just a month after the Deering was found abandoned. Could both ships have fallen victim to the same pirate gang? The investigation took a surprising turn when Herbert Hoover, then Secretary of Commerce, received an anonymous letter claiming that the crew of the Deering had been captured by a Soviet vessel and taken to Russia. This coincided with the Red Scare that had gripped America after the Russian Revolution, and for a time, investigators seriously pursued the possibility of Bolshevik involvement. However, no evidence ever materialized to support this theory, and it was eventually dismissed as a product of the era's political paranoia. Some researchers pointed to a series of strange events that preceded the Deering's final voyage. Before departing, Captain Wormel allegedly told his wife that he felt uneasy about the journey and even made arrangements for her financial security, as if anticipating he might not return. Was this merely the usual caution of a seasoned mariner, or did Wormel have specific reasons to fear this particular voyage? Adding another layer of intrigue, a man named Lawrence Gonzalez was originally scheduled to serve as the Deering's first mate, but canceled at the last minute due to what he described as a premonition of doom. His replacement, a man whose full identity was never conclusively established in the investigation, joined the ship just before departure. Could this mysterious first mate have played a role in whatever transpired aboard the vessel? As the investigation continued without resolution, more outlandish theories emerged. Some speculated about supernatural causes, suggesting the Deering had fallen victim to the same mysterious forces associated with the Bermuda Triangle, though Diamond Shoals lies outside the traditional boundaries of that region. Others proposed that a sudden waterspout or freak wave had washed the entire crew overboard while somehow leaving the vessel intact, a scenario considered physically implausible by maritime experts. After months of investigation, authorities were no closer to solving the mystery. In 1921, the federal government officially abandoned its inquiry, concluding only that the disappearance of the crew of the Carroll A branch. Deering is now, and probably always will be, one of the strangest sea mysteries of all time. The wreck of the Carroll A. Deering remained stranded on Diamond Shoals for several months, becoming something of a tourist attraction as curious onlookers hired boats to view the ghostly vessel. Eventually, the schooner was deemed a hazard to navigation, and salvage operations began. However, before much could be recovered, a storm broke the ship apart in March 1921. Pieces of the once proud vessel washed ashore along the Outer Banks for years afterward, with some local families incorporating timber from the Deering into their homes, perhaps unwittingly preserving pieces of one of maritime history's greatest mysteries. In the centuries since the Deering's discovery, researchers and maritime historians have continued to investigate the case, applying modern analytical techniques and historical context to the limited evidence. While no definitive answer has emerged, certain theories have gained prominence among serious researchers. The most plausible explanation, according to many maritime historians, combines elements of several theories. It suggests that a mutiny did indeed occur, possibly triggered by the harsh treatment that was sometimes common aboard commercial vessels of the era. After overthrowing Captain Wormel and any loyal crew members, the mutineers attempted to navigate the vessel themselves, but lacked the skills to keep the Deering off the treacherous Diamond Shoals. After the grounding, realizing they would face severe punishment if caught, the mutineers may have fled in the lifeboats, possibly making for the isolated barrier islands of North Carolina's Outer Banks. From there, they could have dispersed, perhaps even assuming new identities in the chaos of post-World War I America. This would explain the missing navigation equipment and logbooks, which they would have taken to prevent authorities from tracking the ship's actual course. Supporting this theory is the fact that several unidentified bodies washed ashore along the Outer Banks in the weeks following the Deering incident. Official reports dismissed any connection, but local folklore persisted that these were the bodies of Captain Wormel and loyal crew members killed during the mutiny. Another theory gaining traction with modern researchers focuses on the Deering's encounter with extreme weather. Meteorological records confirm that a significant storm system moved through the area around the time of the ship's disappearance. Modern understanding of rogue waves, enormous, unpredictable waves that can reach heights of over 100 feet, suggests that such a phenomenon could potentially wash crew members from a vessel's deck while leaving the ship structurally intact. Under this scenario, the crew might have been swept overboard during a sudden catastrophic wave event. The sighting at Cape Lookout might be explained as the few surviving crew members, possibly including inexperienced deckhands, attempting to manage the vessel after losing the captain and senior officers. Their subsequent disappearance could have occurred during a second weather event or a desperate attempt to abandon the drifting vessel as it approached Diamond Shoals. The piracy theory, while popular in the sensationalist press of the 1920s, has generally fallen out of favor with serious researchers. The absence of other evidence of organized piracy in American waters during this period, combined with the logistical challenges of transferring an entire crew from one vessel to another in open seas, makes this explanation less plausible than others. What makes the Carroll A. Deering case particularly significant in the annals of maritime mysteries is not just the disappearance itself, but the context in which it occurred. The year 1921 represented a pivotal moment in shipping history, as sailing vessels like the Deering were rapidly being replaced by steam-powered ships. The Deering was one of the last commercial sailing vessels of her size still operating, a relic of a dying era navigating waters increasingly dominated by modern technology. This transitional period created unique vulnerabilities and tensions. Skilled sailing ship officers were becoming scarce, as younger sailors trained on steam vessels instead. Crews often consisted of a mix of older, experienced hands and less qualified individuals who couldn't find work on more desirable steamships. The friction between old ways and new, between traditional seamanship and industrial maritime labor, may have contributed to whatever transpired aboard the Deering during her final voyage. The cultural impact of the Deering mystery has been significant and enduring. The case has inspired countless novels, films, and television episodes, often serving as the template for fictional ghost ship narratives. The image of a fully rigged sailing ship, abandoned but intact, has become an iconic representation of maritime mystery in American culture. For the communities of North Carolina's Outer Banks, the Deering has become part of local folklore and identity. The vessel's story is told in museums and historic sites throughout the region, and descendants of the lighthouse keepers and Coast Guard personnel involved in the discovery still relate family stories passed down through generations. The Carroll A. Deering's mystery resonates particularly strongly because it occurred not in the distant past or remote seas, but in American waters during the modern era. The investigation involved agencies that still exist today, using methods recognizable to modern criminal investigation. Yet despite these advantages, the case remains as opaque now as it was a century ago. As technology advances, there remains hope that some aspects of the mystery might eventually be resolved. Modern side-scan sonar and underwater archaeology techniques could potentially locate the scattered remains of the Deering on the seabed near Diamond Shoals. If the ship's bell, builder's plate, or other identifiable artifacts could be recovered, they might yield new clues through advanced forensic analysis unavailable to the original investigators. Until such discoveries are made, the Carroll A. Deering will remain what it has been for a century, one of the most baffling ghost ship mysteries in maritime history, a vessel that sailed into legend, leaving behind nothing but questions, theories, and the enduring human fascination with the unexplained. Now, let's sail toward another vessel whose crew vanished without explanation. Story 31, Joyita Ship, the Pacific's Perfect Mystery. From the haunting tale of the Carroll A. Deering, we now sail across the world to the South Pacific, where another ghost ship mystery unfolded under equally baffling circumstances. The MV Joyita was a 69-foot merchant vessel that disappeared in the South Pacific in 1955. What makes this case particularly strange is that the ship was found 5 weeks later, partially submerged but still afloat, yet her 25 passengers and crew had vanished without a trace. The vessel, designed to be unsinkable, showed no signs of distress that would necessitate abandonment. The radio was tuned to the international distress frequency, but hadn't been used. A doctor's bag was found open with bloody bandages, 4 tons of cargo were missing, and all the ship's navigational equipment and firearms had disappeared. Most chillingly, the ship's chronometer had stopped at 10:25, and the captain's log was gone. What happened to the 25 people aboard the Joyita, and why would they abandon an unsinkable vessel only to disappear in the vast Pacific? This mystery has baffled maritime experts for nearly 7 decades, and remains one of the most perfect maritime enigmas ever documented. In the early 1950s, the South Pacific was a region in transition. World War II had ended less than a decade earlier, leaving behind a complex legacy of military installations, disrupted local economies, and new political arrangements. Colonial powers were beginning their slow withdrawal, while island nations were taking initial steps toward independence. Against this backdrop of change, inter-island commerce was booming, creating demand for vessels to transport people, goods, and supplies between scattered archipelagos. The MV Joyita was perfectly positioned to serve this growing market. Built in 1931 as a luxury yacht for Hollywood director Roland West, the 69-foot wooden vessel had been repurposed as a patrol boat during World War II before being converted to merchant service in the post-war Pacific. Her new owner, British sailor Captain Thomas Dusty Miller, had renovated her specifically for the Pacific Island trade, transporting cargo and passengers between Samoa, Fiji, and the smaller islands that dot this vast oceanic region. The Joyita had several notable features that would later become critical to understanding her mystery. Most importantly, her hull contained a significant amount of cork insulation, making her virtually unsinkable. Even fully flooded, she would remain afloat. This design characteristic would prove prophetic in the strange events to come. On October 3rd, 1955, the Joyita departed the port of Apia in Samoa, bound for the Tokelau Islands, approximately 270 miles to the north. The journey should have taken around 2 days. On board were 16 passengers and 9 crew members, a total of 25 people whose fates would become one of maritime history's most enduring mysteries. The passenger list included government officials, local traders, and a prominent doctor, Alfred Andy Dennis, who was traveling to perform urgently needed surgery. Captain Dusty Miller was not aboard for this voyage. Instead, the vessel was under the command of Captain Rupert Morehouse, 37, an experienced British sailor with a spotless professional record. The Joyita's departure was already inauspicious. The ship was scheduled to leave at 5 in the morning, but engine problems delayed departure until 5 in the evening, putting the vessel 12 hours behind schedule from the start. These mechanical issues were not considered serious at the time, though they would later feature prominently in theories about what happened. When the Joyita failed to arrive at her destination on October 5th, no immediate alarm was raised. Communication in the region was limited, and delays were common in the island trade. It wasn't until a full 48 hours after her expected arrival that officials in Tokelau finally sent a message to Samoa reporting that the vessel had not appeared. This delayed response meant that search and rescue operations didn't begin until October 8th, 5 days after the Joyita had departed. The Royal New Zealand Air Force conducted an extensive aerial search, covering roughly 100,000 square miles of ocean, but found no sign of the vessel or any debris or survivors. After several days, the search was reluctantly abandoned, and the Joyita, along with her 25 souls aboard, was presumed lost at sea. Then came the shocking discovery. On November 10th, 1955, 5 weeks after she had disappeared, the Joyita was found drifting 600 miles off course, near Vanua Levu in the Fiji Islands. The vessel was listing heavily to port, with her deck awash and her superstructure riding just a few feet above the waterline. But remarkably, she was still afloat, just as her unsinkable design promised. What made this discovery truly baffling was that there was no sign of the 25 people who had been aboard. They had vanished completely, along with the ship's logbook, navigational equipment, firearms, and the doctor's medical bag. Even more puzzling, the Joyita's 3 lifeboats were missing, suggesting a deliberate abandonment of the vessel. The boarding party that examined the derelict Joyita found a scene that raised far more questions than it answered. The ship's engines were covered with mattresses, perhaps in an attempt to stem flooding. The radio, although water damaged, was set to the international distress frequency of 2,182 kHz. But later examination revealed it had been incorrectly wired to the ship's batteries and had a transmission range of only about 2 miles instead of its normal range of 200 miles. Most ominously, the ship's chronometer had stopped at 10:25, possibly marking the moment of some catastrophic event. Inside the captain's cabin, investigators found blood-stained bandages scattered about, suggesting that someone had been treated for injuries. The doctor's bag lay open, its contents apparently used. 4 tons of cargo were missing from the holds, including a shipment of medical supplies. And while the vessel had taken on water, her hull was intact with no damage that could explain the flooding. The official inquiry that followed focused primarily on the vessel's mechanical condition. It concluded that the Joyita had experienced engine failure, followed by progressive flooding through a leaking cooling pipe. This flooding would eventually have disabled the engines completely and compromised the vessel's electrical systems, including the radio. According to this theory, Captain Morehouse, unable to call for help and believing his vessel was sinking, had ordered everyone into the lifeboats. This decision, while seemingly reasonable to a captain unaware of the Joyita's unsinkable qualities, would have been a fatal error. The small lifeboats would have had virtually no chance of survival in the vast Pacific, especially if attempting to reach land hundreds of miles away. But this explanation left numerous questions unanswered. Why were the navigational equipment, firearms, and logbook missing? Why had 4 tons of cargo disappeared? Why were bloody bandages found in the captain's cabin? And perhaps most fundamentally, why would an experienced captain like Morehouse abandon a vessel that was still clearly afloat for the much greater peril of open lifeboats? In the decades since, numerous alternative theories have emerged to explain the Joyita mystery. One of the most prominent involves Japanese fishing vessels operating illegally in territorial waters. In the post-war Pacific, Japanese fishing fleets were expanding rapidly, sometimes encroaching on restricted areas. According to this theory, the Joyita may have encountered such a vessel, leading to a confrontation that turned violent. The Japanese fishermen, desperate to avoid detection for their illegal activities, might have boarded the Joyita, removed her crew and passengers, and taken the navigational equipment to prevent authorities from pinpointing the location of the encounter. Supporting this theory was the regional context. Tensions regarding fishing rights were indeed high in the 1950s Pacific, and confrontations between local vessels and foreign fishing boats were not uncommon. The missing firearms and navigational equipment would make sense in this scenario, as would the blood-stained bandages suggesting a violent encounter. Another theory focuses on cargo theft and mutiny. The missing 4 tons of cargo, particularly the valuable medical supplies, might have tempted crew members or passengers to seize the goods. Under this scenario, a group of conspirators could have overpowered the captain and loyal crew members, transferred the valuable cargo to a rendezvous vessel, and forced everyone else into lifeboats or thrown them overboard. The conspirators would then have escaped on the rendezvous vessel, leaving the Joyita to drift empty. Some researchers have suggested that Cold War espionage might explain the Joyita's fate. The 1950s South Pacific was a region of significant strategic interest, with the United States conducting nuclear tests at Bikini Atoll and various powers jockeying for influence among the emerging island nations. Perhaps the Joyita had accidentally witnessed something she shouldn't have, a secret military test or covert operation, and was intercepted to silence those aboard. This theory, while speculative, would explain why the vessel was found so far off course and why critical items like the logbook were missing. It might also explain why no bodies or lifeboat debris were ever discovered if a systematic effort had been made to eliminate all evidence. The bloody bandages found in the captain's cabin have led some to theorize that violence broke out aboard the Joyita. Perhaps a passenger went berserk, attacking others and forcing an emergency evacuation. The presence of Dr. Dennis's medical bag with some contents apparently used lends some credence to this idea. If several people were seriously injured, Captain Morehouse might have made the difficult decision to evacuate the wounded to lifeboats in hopes of reaching land more quickly than the disabled Joyita could manage. Natural phenomena have also been proposed as explanations. A sudden squall or rogue wave might have washed some crew members overboard, injured others, and damaged the vessel. The survivors, believing the Joyita was doomed, might have taken to the lifeboats. Alternatively, the ship might have been struck by a tsunami generated by undersea seismic activity, creating catastrophic conditions on board without leaving obvious structural damage. Some locals in the South Pacific suggested that the Joyita had fallen victim to modern piracy. Remote islands in the region occasionally harbored outlaw groups who might have seized the vessel, taken what they wanted, and disposed of the witnesses. The valuable cargo, firearms, and navigational equipment would all have been prize targets for such pirates. More exotic theories have also emerged over the years. Some have suggested that the Joyita encountered an unidentified submarine object, the underwater equivalent of a UFO, leading to the disappearance of those aboard. Others have proposed that the vessel sailed through a temporary space-time anomaly, similar to those theorized to exist in the Bermuda Triangle. These more speculative explanations, while lacking scientific support, speak to the profound mystery surrounding the Joyita's fate. What makes the Joyita case so perfectly perplexing is that each theory seems to explain some elements of the mystery while leaving others unresolved. The official explanation of engine failure and abandonment doesn't account for the missing equipment and cargo. The piracy theory doesn't explain why the attackers would have left a valuable vessel like the Joyita drifting instead of seizing her. The mutiny scenario fails to explain why no one involved ever resurfaced to enjoy their stolen goods. Perhaps the most rational approach is to consider that multiple factors may have converged to create this mystery. An initial mechanical failure, followed by injuries aboard, compounded by severe weather and panic-driven bad decisions, could collectively explain many of the puzzling elements without requiring elaborate conspiracies or supernatural forces. For the families of the 25 people who vanished aboard the Joyita, the decades since 1955 have brought no closure. No bodies were ever recovered, no definitive explanation ever established. The vessel herself was refloated, repaired, and returned to service, only to suffer further mishaps that reinforced her reputation as cursed. After changing hands several times, she was eventually scrapped in the 1960s, taking whatever secrets her timbers might have held to her final destruction. The legacy of the Joyita mystery extends beyond the personal tragedy of those lost. It has become a cautionary tale in maritime circles about the dangers of abandoning a vessel prematurely, even when the situation seems dire. Modern maritime safety training emphasizes that a damaged ship, however compromised, often remains safer than lifeboats in open ocean, a lesson that might have saved lives had it been more widely understood in 1955. For researchers and maritime historians, the Joyita represents the perfect mystery, well documented yet completely unexplained, with enough tantalizing clues to support multiple theories but insufficient evidence to confirm any of them conclusively. Like the Mary Celeste before her and other ghost ships since, the Joyita continues to captivate because she challenges our assumption that modern vessels in relatively well-traveled waters simply don't disappear without explanation. In the decades since the Joyita incident, advances in technology have dramatically reduced the likelihood of similar mysteries occurring. Modern vessels carry emergency position indicating radio beacons that automatically signal their location in a crisis. Satellite tracking systems monitor commercial ships continuously. Global communication networks ensure that distress calls reach rescue authorities almost instantaneously. Yet despite these advances, ships still occasionally disappear in circumstances that defy easy explanation. The ocean, covering more than 70% of our planet and reaching depths of over 7 miles, remains in many ways as mysterious as outer space, a vast frontier where human presence is fleeting and tenuous. The MV Joyita, found floating but abandoned 600 miles from her intended course, her chronometer frozen at 10:25 and her people vanished without a trace, reminds us that even in the modern age, the sea still keeps some secrets. Whatever fate befell the 25 souls aboard on that October night in 1955, it remains locked in the silent depths of the Pacific, an enduring enigma of the ocean's dark waters. Story 32. INS Dakar, Submarine Disappearance. Israel's Underwater Tragedy. From the enigmatic abandonment of the MV Joyita, we now descend into the depths of the Mediterranean to investigate one of the Cold War's most perplexing submarine mysteries, the disappearance of the INS Dakar. In January 1968, this newly acquired Israeli submarine vanished without a trace while sailing from Portsmouth, England to Haifa, Israel. For 31 years, the fate of the Dakar and her 69 crewmen remained unknown, despite extensive international search efforts. What made this case particularly mysterious was that the submarine had been in regular radio contact until her final cryptic message, which was cut off mid-transmission. When the wreckage was finally located in 1999, it lay scattered 9,800 feet deep in a location far off her planned route, raising more questions than it answered. Was it mechanical failure, a collision with a surface vessel, a Soviet attack during the height of Cold War tensions, or something even more sinister that sent the Dakar to her doom? Let's explore one of the most tragic submarine mysteries that took 3 decades to partially solve, yet remains shrouded in unanswered questions. The story of the INS Dakar begins not with her disappearance, but with the young nation of Israel's desperate quest to build its naval defenses in a hostile region. By the mid-1960s, Israel faced existential threats from neighboring Arab states, many of which openly called for its destruction. The Israeli leadership recognized that submarine capabilities would provide a crucial strategic advantage, offering both intelligence-gathering potential and a possible second strike capability if the worst should occur. In 1965, Israel purchased 3 T-class submarines from the British Royal Navy. These vessels had been built in the 1940s for service in World War II, but had since been extensively modernized. One of these submarines, formerly HMS Totem, was renamed INS Dakar, Hebrew for porpoise, and prepared for service in the Israeli Navy under the command of Lieutenant Commander Yaakov Ra'anan, a 35-year-old veteran officer. The Dakar was a formidable vessel for her time. Stretching 295 feet and displacing 1,570 tons when submerged, she had been retrofitted with modernized equipment, enhanced diesel engines, and improved snorkel capabilities that allowed her to operate submerged for extended periods. After the purchase, the submarine underwent a 9-month refit at Portsmouth Dockyard to prepare her for Israeli service and the different operational requirements of the Mediterranean compared to the North Atlantic where she had previously served. On January 9, 1968, following sea trials and with her Israeli crew trained and ready, the Dakar departed Portsmouth, beginning what should have been a routine delivery voyage to her new home port of Haifa. The journey was planned to take about 14 days, with the submarine scheduled to arrive in Israel on January 29th, symbolically timed to coincide with Israel's upcoming Independence Day celebrations. The first leg of the journey proceeded without incident. The Dakar passed through the Bay of Biscay and entered the Mediterranean via the Strait of Gibraltar, maintaining regular radio contact with Israeli naval headquarters as planned. On January 15th, Commander Ra'anan radioed that he intended to arrive ahead of schedule, a decision that would later be scrutinized as investigators tried to understand why the submarine deviated from her planned route and speed. The last verified position report from the Dakar came on January 24th, placing her about 30 miles off the southern coast of Cyprus. The submarine was on the final leg of her journey, with less than 250 miles remaining to Haifa. Then, at midnight between January 24th and 25th, Israeli Naval Headquarters received a routine transmission from the Dakar. This would be the last complete message from the submarine. Approximately 22 minutes after midnight, the Dakar began another transmission, but this one was abruptly cut off mid-message. After that, silence. Attempts to contact the submarine received no response. The Dakar and her 69 crewmen had vanished. Israel immediately launched search and rescue operations, soon joined by vessels and aircraft from the United States, Britain, Greece, Turkey, and even Lebanon, despite its hostile relationship with Israel. This multinational effort covered thousands of square miles of the Mediterranean between Cyprus and Israel, but found no debris, oil slick, or distress signals, nothing to indicate what had happened to the submarine or where exactly she had gone down. The only clue came on January 27th, when a radio buoy identified as belonging to the Dakar washed ashore near the Israeli port city of Khan Yunis, now part of the Gaza Strip. This emergency buoy was designed to be released by a submarine in distress and should have been attached to the vessel by a cable. The fact that it had broken free suggested a catastrophic event, but provided little information about the submarine's location when disaster struck. For the next 31 years, the fate of the Dakar would remain one of the most enduring mysteries of modern naval history. The disappearance occurred at the height of the Cold War, and just months after the Six-Day War had dramatically increased tensions in the Middle East. This context spawned numerous theories, ranging from the technical to the conspiratorial. The most straightforward explanation was that the Dakar had suffered a catastrophic mechanical failure. T-class submarines were aging vessels with known issues, particularly with their snorkel systems. If the snorkel had failed while the submarine was running on diesel power underwater, seawater could have entered the boat, potentially leading to loss of control, an uncontrollable dive, and hull collapse at depth. Supporting this theory was the fact that several submarines of similar vintage had been lost to mechanical failures in the preceding decades, including the USS Thresher in 1963 and the French submarine Minerve, which disappeared in the western Mediterranean just 4 days before the Dakar. Another theory centered on the possibility of a collision. The Mediterranean was and remains one of the world's busiest shipping lanes, with thousands of vessels traversing its relatively confined waters each day. If the Dakar had risen to periscope depth or surfaced in the path of a large merchant vessel, a collision could have damaged the submarine severely enough to cause rapid flooding and sinking. If the merchant vessel was unaware of the collision, as sometimes happens with submarine accidents, they might have continued on their way, never reporting the incident. The geopolitical situation at the time gave rise to more ominous theories. Some speculated that the Dakar might have been deliberately attacked by Soviet naval forces monitoring her journey. The Soviets had a significant Mediterranean presence and maintained close relationships with several Arab states opposed to Israel. A Soviet attack on the Dakar would have been a highly provocative act, potentially bringing the Cold War to a hot flashpoint, which is why many analysts considered this scenario unlikely despite the tensions of the era. Egyptian or Syrian involvement was also suggested, though both countries denied any knowledge of the submarine's fate. Israel had decisively defeated both nations in the Six-Day War just 7 months earlier, and the possibility of revenge against a valuable Israeli military asset could not be entirely dismissed, though most naval experts considered it highly improbable that either country had the capability to detect and attack a submarine in international waters. More exotic theories emerged over the years. Some suggested that the Dakar had been hijacked and was being held in a secret harbor, though this became increasingly implausible as time passed with no demands or evidence. Others proposed that the submarine had suffered a catastrophic accident involving secret weapons or nuclear material, though there was no evidence the Dakar carried any such systems. For the families of the 69 crewmen, the decades without answers brought unimaginable pain. In Israeli culture, where military service is universal and the Navy holds a special place of respect, the Dakar became a national symbol of sacrifice and unresolved loss. Memorials were erected, annual ceremonies held, and the story of the missing submarine entered the country's collective consciousness. The mystery might have remained unsolved forever, if not for advances in deep-sea exploration technology. In 1999, a renewed effort to locate the Dakar was launched, using the Nauticus, an American deep-sea search vessel equipped with advanced sonar and remotely operated vehicles. After meticulous search covering 24,000 square miles of seabed, the impossible was achieved. On May 28, 1999, the wreckage of the Dakar was finally located. The discovery brought closure but also new questions. The submarine was found lying at a depth of 9,800 feet, 3,000 meters, much deeper than the Dakar's calculated crush depth, in a location approximately 300 miles west of the Israeli coast. This position was significantly off the submarine's expected route, suggesting either a major navigational error or a deliberate deviation for unknown reasons. The wreckage was in a condition consistent with a catastrophic hull collapse. The pressure hull had been crushed by the immense pressure of the deep ocean, and the submarine had broken into two major sections, with debris scattered across a wide area of the seabed. The conning tower and part of the sail were found intact, along with other recognizable components that conclusively identified the wreck as the Dakar. Later expeditions to the site recovered artifacts, including the submarine's bridge chair, crew tags, and most symbolically, the Dakar's steering wheel and broken compass. In 2000, these items were returned to Israel and placed in a memorial at the Naval Museum in Haifa. That same year, a state funeral was held for the 69 crewmen, whose remains had never been recovered but were now presumed entombed in their vessel on the Mediterranean seafloor. While the discovery of the wreckage confirmed the Dakar's fate, it did not provide definitive answers about what caused the disaster. The Israeli Navy's official investigation concluded that the most probable cause was a catastrophic technical failure, likely involving the snorkel system, that led to uncontrolled flooding and a terminal dive beyond the submarine's crush depth. This conclusion was based on the condition of the wreckage, historical knowledge of T-class submarine vulnerabilities, and the absence of evidence supporting more sinister explanations. However, some aspects of the case remain puzzling. Why was the Dakar so far off her planned course? Commander Ra'anan had radioed his intention to arrive early. Was he taking a shortcut or conducting an unplanned exercise? Why did the emergency buoy wash ashore near Gaza when the wreckage was found hundreds of miles to the northwest? And what caused the final transmission to be cut off mid-message? Some naval analysts have suggested that the Dakar might have been attempting to tail or monitor Soviet vessels in the region, a common Cold War practice that could explain the deviation from her expected route. Others have proposed that Commander Ra'anan might have been conducting deep diving tests to evaluate the submarine's capabilities, potentially exceeding safety parameters in the process. The truth may never be fully known. The Mediterranean keeps its secrets well, and the extreme depth of the wreckage makes detailed forensic examination challenging even with modern technology. What is certain is that 69 young men lost their lives in the prime of their careers, leaving behind families who waited decades for even partial answers. The legacy of the Dakar extends beyond the tragedy itself. The disaster led to significant changes in Israeli naval protocols, particularly regarding communication requirements and emergency procedures for submarines. It also influenced the design and safety features of subsequent submarines acquired by Israel, including fail-safe systems specifically intended to prevent similar catastrophes. For submarine forces worldwide, the Dakar joins a solemn list of vessels lost in peacetime, a reminder of the inherent dangers of undersea operations, even absent the threats of combat. The pressure hull of a submarine represents the thinnest of barriers between life and death, with little margin for error when operating in the unforgiving environment of the deep ocean. The INS Dakar now rests in her accidental tomb, 9,800 feet beneath the Mediterranean waves. The discovery of her wreckage brought a measure of closure to a nation that had waited 31 years for answers, but the full story of her final voyage remains written only in the silence of the deep, a maritime mystery only partially solved, a tragic reminder of the sea's power to take without explanation or apology. Now, let's investigate another submarine that vanished without a trace, leaving behind questions that persist to this day. Story 33, Minerve Submarine Disappearance, France's Enduring Naval Mystery. From the tragic loss of the INS Dakar, we now turn to another submarine mystery that occurred almost simultaneously but remained unsolved for even longer. Just 4 days before the Dakar vanished, the French submarine Minerve disappeared in the western Mediterranean with 52 sailors aboard. On January 27, 1968, the diesel-electric submarine was returning to her home port of Toulon after a training exercise when she radioed that she would arrive in port within an hour. That message was the last anyone would hear from the Minerve. Despite an immediate and massive search operation involving aircraft, surface vessels, and even experimental deep-sea submersibles, no trace of the submarine was found. For over 51 years, the Minerve's location remained unknown until modern technology finally located the wreckage in 2019, broken into 4 pieces more than 7,800 feet beneath the surface. But while we now know where the Minerve came to rest, what caused this modern warship to sink just miles from safety remains as mysterious as ever. Was it a catastrophic mechanical failure, a collision with a larger vessel, or something more sinister during these tense Cold War years? Let's explore this enduring naval mystery that haunted the French nation for over half a century. In the annals of submarine disasters, few cases have remained as enigmatic for as long as the disappearance of the French submarine Minerve. Built as part of France's post-World War II naval modernization program, the Minerve was a Daphne-class submarine, a design that represented the cutting edge of conventional, non-nuclear, submarine technology in the 1960s. At 58 meters long and displacing 869 tons when submerged, she was a compact but capable vessel, designed primarily for coastal defense and reconnaissance operations in the Mediterranean. The Minerve had entered service in 1964 and was considered a reliable, well-maintained vessel with an experienced crew. Her commander, Lieutenant André Fauve, was just 36 years old but highly regarded within the French Navy, known for his meticulous attention to detail and professionalism. Under his leadership, the submarine had completed numerous successful patrols and exercises without incident. January 1968 found the western Mediterranean gripped by unusually severe winter weather. Strong mistral winds had churned the sea into a frothing cauldron of whitecaps and swells, creating treacherous surface conditions, even for much larger vessels. Despite this, the Minerve had been conducting routine training exercises approximately 25 nautical miles off the coast of Toulon, France's primary naval base on the Mediterranean. On the morning of January 27th, the submarine was returning to port after completing these exercises. At 7:55 a.m., Lieutenant Fauve radioed to Naval Headquarters that the Minerve would arrive at her berth in Toulon by 1:35 p.m. that same day. This routine message gave no indication of any problems aboard the vessel. The submarine was operating on snorkel, running her diesel engines while traveling just below the surface, a standard procedure that allowed the boat to recharge her batteries while maintaining a low profile. The Minerve never arrived. When the submarine failed to appear at the expected time, French naval authorities initiated standard communication protocols, attempting to reach her via radio. When these efforts yielded no response, concern quickly escalated to alarm. By evening, a full-scale search and rescue operation had been launched, with surface vessels and aircraft scouring the area where the Minerve was last believed to be. The initial search focused on the submarine's expected route from her last reported position to Toulon. Aircraft dropped sonobuoys, specialized underwater listening devices, hoping to detect any sound that might emanate from the Minerve if she were disabled but intact on the seabed. Surface ships used early forms of side-scan sonar to search for any large object on the seafloor. Within days, the search had expanded dramatically. The French Navy was joined by American naval forces, including the USS Mizar, a research vessel equipped with some of the most advanced underwater detection technology available at the time. The Mizar had been instrumental in locating the wreckage of the USS Thresher, an American nuclear submarine lost in 1963, and brought valuable experience and capabilities to the search. Even cutting-edge deep-sea technology was deployed. The French bathyscaphe Archimede, an early deep-diving vessel, capable of reaching great depths, conducted multiple dives in the search area. The United States sent the submersible Trieste II, successor to the vessel that had reached the bottom of the Mariana Trench, to assist in the deep water search. Despite this unprecedented international effort, no trace of the Minerve was found, no oil slick, no debris, no emergency signals. It was as if the submarine and her 52 crew members had simply vanished from the Mediterranean. After several weeks of intensive searching without results, hope of finding survivors gradually faded. The search was scaled back, though efforts to locate the wreckage continued intermittently for years. For the families of the 52 men lost aboard the Minerve, the lack of physical evidence or clear explanation for the disaster made the process of grieving and acceptance particularly difficult. As investigators sought to understand what might have happened to the Minerve, several theories emerged. Each had its supporters and detractors, but without physical evidence from the wreckage, none could be conclusively proven or disproven. The most widely accepted explanation focused on mechanical failure, particularly related to the submarine's snorkel system. Daphne-class submarines were known to have certain vulnerabilities when operating on snorkel in rough seas. If waves crashed over the snorkel intake, emergency valves would close automatically to prevent water from entering the boat. However, this sudden closure could create a dangerous vacuum inside the submarine, potentially causing control problems or even structural damage. Under this scenario, the Minerve might have experienced a snorkel failure while battling the heavy seas reported on January 27th. This could have led to a sudden and catastrophic loss of control, causing the submarine to plunge too deep too quickly, exceeding her crush depth and imploding under the immense pressure. The speed of such a disaster would explain the absence of distress signals, as the crew would have had no time to react before the pressure hull collapsed. Supporting this theory was the fact that another Daphne-class submarine, the Israeli INS Dakar, disappeared under mysterious circumstances just 4 days before the Minerve, on January 25, 1968. This unlikely coincidence suggested a possible design flaw in this class of submarines that might have contributed to both disasters. Additionally, in 1970, yet another Daphne-class submarine, the Greek Eurydice, would be lost with all hands in similar circumstances off the coast of Cape Matapan. A second theory centered on the possibility of a collision. The waters off Toulon were busy with commercial shipping and naval traffic, and visibility on that stormy January morning would have been poor. If the Minerve had risen to periscope depth, or was operating just below the surface on snorkel, she might have been struck by a surface vessel unaware of her presence. Such collisions had occurred before and since. In 1968, the USS Scorpion, an American nuclear submarine, was one of several vessels suspected to have been lost due to an unreported collision, though later evidence pointed to other causes. More recently, in 2001, the USS Green Neville accidentally struck and sank a Japanese training vessel, the Eihimaru, illustrating how such accidents can occur even with modern navigation technology. A collision severe enough to breach the Minerve's pressure hull would have resulted in immediate flooding and probable loss of the vessel. If the surface ship involved was unaware of the collision or chose not to report it, this would explain the absence of distress calls or reports from other vessels in the area. More controversial theories emerged in the Cold War context of 1968. Some speculated that the Minerve might have been accidentally struck by a NATO vessel during undisclosed exercises, with the incident subsequently covered up to avoid diplomatic complications. Others suggested Soviet involvement, noting the significant Russian naval presence in the Mediterranean during this period and the high level of international tensions. However, most naval experts considered these scenarios highly unlikely. There was no credible evidence of foreign military involvement, and the political and diplomatic consequences of such an incident, if discovered, would have far outweighed any potential benefits of a cover-up. As decades passed without the discovery of the wreckage, the Minerve joined the ranks of enduring maritime mysteries like the USS Scorpion and the INS Dakar. For France, the loss became a painful chapter in the nation's naval history, with annual commemorations remembering the 52 men who never returned to port. The families of the lost crew formed an association that kept pressure on successive French governments to continue the search for the submarine. Their persistence would eventually prove crucial in the final resolution of the mystery decades later. The technological limitations of the 1960s presented formidable obstacles to locating a wrecked submarine in the deep Mediterranean. The undersea search capabilities of that era, while cutting edge for their time, were primitive compared to modern systems. The side-scan sonar available in 1968 had limited range and resolution, especially in the complex terrain of the Mediterranean seafloor with its canyons, ridges, and sediment-filled basins. Additionally, the search area was vast and imprecisely defined. Without exact knowledge of the Minerve's final movements or the ocean currents at the time of her loss, searchers were forced to cover an enormous area, much of it at depths challenging even for modern equipment. For decades, the mystery of the Minerve remained unsolved, the wreckage unfound. Occasional renewed search efforts using incrementally improved technology failed to locate the submarine. By the early 21st century, many assumed the wreck would never be found, lost forever in the depths of the Mediterranean. Then came a breakthrough that would finally bring closure to one of France's longest-standing naval mysteries. In 2018, responding to renewed appeals from the families of the lost crew, French Defense Minister Florence Parly announced a new search effort for the Minerve. This wasn't merely a symbolic gesture, but a commitment backed by the latest in deep-sea exploration technology. The French Navy partnered with private companies specializing in underwater searches, including Ocean Infinity, which had recently located the wreckage of the Argentine submarine Ara San Juan, lost in 2017. These companies brought sophisticated capabilities including autonomous underwater vehicles equipped with advanced sonar systems, magnetometers, and high-definition cameras. Crucially, The new search incorporated modern oceanographic modeling. Experts reanalyzed the currents, weather conditions, and other environmental factors from January 1968, using computer simulations far more sophisticated than anything available when the Minerve was lost. This allowed the search team to narrow the potential search area significantly. Success came swiftly. On July 21, 2019, more than 51 years after the submarine disappeared, the wreckage of the Minerve was finally located approximately 45 kilometers off the coast of Toulon, in water 2,370 meters or 7,800 feet deep. The discovery was announced by Florence Parley on Twitter. "We have just found the Minerve. It's a success, a relief, and a technical feat. I think of the families who have been waiting for this moment so long." The submarine was found broken into 4 major sections, consistent with a catastrophic implosion under extreme pressure. The largest piece was the main hull section, with the bow, stern, and debris field scattered nearby on the seabed. The wreckage was positively identified using the vessel's unique identification numbers still visible on parts of the hull. For the families of the 52 crew members, the discovery brought long-awaited closure. Hervé Fauve, son of the Minerve's commander Lieutenant André Fauve, expressed the bittersweet emotions shared by many relatives. "It's the end of a long wait, which was very painful. The location of the wreck is a relief for us and a moment of great emotion. Now we can complete our mourning." A memorial ceremony was held at sea above the wreck site, attended by relatives of the crew, naval officials, and representatives of the French government. Wreaths were laid on the water, and a commemorative plaque was placed on the seabed near the wreckage. The French Navy declared the site a maritime grave, protected from disturbance or salvage attempts out of respect for those entombed within. While the discovery of the wreckage confirmed the final resting place of the Minerve and her crew, it did not provide definitive answers about what caused the disaster. The fragmented condition of the submarine was consistent with a catastrophic implosion, but whether this resulted from mechanical failure, a collision, or some other cause remained uncertain. French naval authorities indicated that they would not attempt to raise the wreckage, citing both technical challenges and respect for the site as a war grave. Without direct examination of the hull and internal systems, determining the exact sequence of events that led to the Minerve's loss remains difficult. However, the location and condition of the wreckage did allow some conclusions to be drawn. The fact that the submarine was found relatively close to her last reported position suggests that whatever happened occurred suddenly without allowing the crew time to substantially change course or send distress signals. The fragmentation pattern of the hull is consistent with a rapid descent beyond crush depth, supporting the theory of a catastrophic loss of control, possibly due to snorkel failure in the stormy conditions. The timing of the loss, just days before the disappearance of the Israeli Dakar and 2 years before the loss of the Greek Eurydice, both submarines of the same class, continues to suggest that a design vulnerability in Daphne-class submarines might have played a role. The proximity in time between these 3 disasters seems too coincidental to be entirely unrelated, pointing to a common factor that made these otherwise reliable vessels vulnerable under certain conditions. For submarine forces worldwide, the discovery of the Minerve offered a sobering reminder of the inherent dangers of undersea operations. Even today, with vastly improved technology, submarines operate in an environment unforgiving of error or mechanical failure. The pressure of the deep ocean remains as implacable as it was in 1968, ready to crush any vessel that descends beyond its structural limits. The Minerve story also highlights how advances in technology can eventually solve mysteries once thought impenetrable. The same deep-sea exploration capabilities that located the Minerve have in recent years found other long-lost vessels, including the USS Indianapolis, ARA, San Juan, and HMS Urge. These discoveries provide not just historical clarification, but emotional closure for the families of those lost at sea. As a postscript to this 5-decade mystery, in 2020, the French Navy released previously classified documents related to the loss of the Minerve. These papers revealed that within days of the disappearance, French military analysts had concluded that a snorkel accident was the most likely cause, but without physical evidence, they could not rule out other possibilities. The documents also showed that the initial search had come tantalizingly close to finding the wreckage, with sonar contacts recorded just a few kilometers from where the submarine was eventually discovered in 2019. The Minerve now rests in the silent darkness of the deep Mediterranean, a memorial to 52 men who set sail one stormy January morning and never returned to the families waiting for them in Toulon. Her discovery after more than half a century reminds us that, while the sea may keep its secrets for decades, persistent searching, technological advancement, and the unwavering determination of those who refuse to forget can eventually bring even the most enduring maritime mysteries to light. Story 34, K-129 Submarine Disappearance. Cold War Mystery and CIA Cover-Up. From the French submarine Minerve, we now surface halfway across the world in the North Pacific, where one of the Cold War's most bizarre and secretive submarine incidents unfolded. In March 1968, the Soviet ballistic missile submarine K-129 disappeared in the Central Pacific, with all 98 crew members aboard. What followed was an extraordinary series of events that reads like a spy thriller. The Soviets conducted a massive but unsuccessful search for their missing vessel, unaware that American underwater surveillance systems had already pinpointed the wreck 16,500 feet below the surface. This led to Project Azorian, one of the most expensive and ambitious covert operations in CIA history. The secret attempt to raise the Soviet submarine and its nuclear missiles from the deep ocean floor using a specially built ship disguised as a deep-sea mining vessel. The official story maintained for decades contained crucial misdirections and outright falsehoods, while the true circumstances of the K-129 sinking remain controversial to this day. Was it a catastrophic internal explosion? A collision with an American submarine, as some Russians still believe, or something even more mysterious? Let's dive into this Cold War enigma where espionage, cutting-edge technology, and geopolitical deception converged in the waters of the Pacific. In the frigid early hours of March 8, 1968, the Soviet Golf II-class submarine K-129 was patrolling in the North Pacific, approximately 1,500 miles northwest of Hawaii. Armed with 3 nuclear-tipped ballistic missiles and carrying a crew of 98 sailors and officers, the diesel-electric submarine was conducting a routine deterrent patrol, one of many such missions undertaken by Soviet submarines during the tense years of the Cold War. Then, without warning or distress call, the K-129 vanished. When the submarine failed to make its scheduled radio check-ins, Soviet naval authorities initiated standard communication protocols, attempting to reach the vessel through various channels. As hours stretched into days with no response, concern mounted. By mid-March, the Soviet Navy had launched a massive search operation, deploying dozens of ships and aircraft to comb a vast area of the Pacific where they believed the submarine might be found. What the Soviets didn't know, and wouldn't learn for decades, was that their search was focused in entirely the wrong area, hundreds of miles from where the K-129 actually lay. The submarine had sunk far outside its expected patrol zone, in waters where the Soviets had no reason to believe it would be operating. Meanwhile, American intelligence had already pinpointed the location of the wreck with remarkable precision. The U.S. Navy operated a sophisticated underwater surveillance system known as SOSUS, Sound Surveillance System, a network of hydrophones placed strategically across the ocean floor to detect and track Soviet submarines. This system had recorded unusual acoustic signatures on March 8th, sounds consistent with a submarine imploding as it sank below crush depth. Based on this intelligence, the Americans knew exactly where the K-129 had come to rest. Approximately 1,500 miles northwest of Hawaii, at a depth of 16,500 feet, or 5,030 meters. This placed the Soviet submarine in international waters, but also raised perplexing questions. Why had the K-129 been operating so far outside its normal patrol area? And what had caused a seemingly well-maintained submarine to sink so catastrophically that it couldn't even send a distress signal? The strategic value of the sunken submarine was immediately apparent to American intelligence agencies. A Soviet ballistic missile submarine would contain cryptographic equipment, codebooks, nuclear warheads, and potentially other intelligence treasures. If these could be recovered, they would provide unprecedented insight into Soviet naval capabilities and nuclear systems at the height of the Cold War. Thus began one of the most extraordinary and expensive covert operations of the Cold War, a project so secret and ambitious that even today, more than 50 years later, many details remain classified. The CIA, working with the U.S. Navy and defense contractor Lockheed Martin, developed a plan to recover the K-129 from depths greater than any successful salvage operation had ever attempted. The project, first codenamed Azorian, and later referred to as Jennifer, centered around the construction of a special deep-sea recovery vessel disguised as a commercial mining ship. This vessel, the Hughes Glomar Explorer, was ostensibly owned by reclusive billionaire Howard Hughes and presented to the world as an experimental deep-sea mining platform designed to extract manganese nodules from the ocean floor, a plausible cover story given the emerging interest in deep-sea mineral exploitation at that time. In reality, the 619-foot, or 189-meter ship was a sophisticated recovery platform custom-built for a single purpose: to lift the 2,700-ton Soviet submarine from the crushing depths of the Pacific Ocean. The technical challenges were enormous. No one had ever attempted to recover such a large object from such extreme depths. The operation would require not only extraordinary engineering innovations, but absolute secrecy to avoid alerting the Soviets. The centerpiece of the Glomar Explorer was its massive capture vehicle, a giant claw-like device designed to descend to the ocean floor, grasp the submarine, and bring it intact to the surface. The ship also contained a moon pool, a retractable section of the hull that could open to the sea below, allowing the capture vehicle to be lowered and the recovered submarine to be brought inside the ship without being visible from the outside. In the summer of 1974, 6 years after the K-129 sank, and after extensive preparation and testing, the Glomar Explorer sailed to the recovery site and began operations. Over several weeks, while Soviet ships occasionally sailed nearby unaware of what was transpiring, the Americans attempted to raise the submarine from the abyss. The recovery was only partially successful. As the capture vehicle lifted the submarine off the seafloor, a mechanical failure occurred. According to declassified information, a section of the claw broke, and only the forward third of the K-129 was recovered, approximately 38 feet, or 11.6 meters, of the submarine's bow section. The remainder of the vessel reportedly fell back to the seabed, taking with it 2 of the nuclear missiles and much of the intelligence material the Americans had hoped to recover. The operation remained secret until February 1975, when the Los Angeles Times published a story revealing aspects of the mission after details were leaked by a defense contractor employee. The CIA scrambled to contain the damage, using what would become an infamous phrase in response to Freedom of Information Act requests. "We can neither confirm nor deny," a response that entered the legal lexicon as the Glomar response, still used by government agencies today when refusing to acknowledge the existence of classified information. Even after the story broke, the full extent of what was recovered and what intelligence was gained remained closely guarded secrets. Declassified documents and statements by former intelligence officials have since revealed that the recovered section included the bodies of 6 Soviet sailors who were given a burial at sea with full military honors, recorded on film but not revealed to the Soviets until decades later. The Americans also reportedly recovered 2 nuclear-tipped torpedoes, portions of the submarine's control room, and various codebooks and communications equipment. What was not recovered were the ballistic missiles, which had been the primary target of the operation. The official U.S. position on the cause of the K-129 sinking, maintained for decades, was that the submarine had suffered an internal catastrophic failure, possibly a missile activation accident, battery explosion, or other mechanical failure that caused it to sink rapidly without time to send distress signals. However, alternative theories have persisted. Some former Soviet and Russian naval officers have maintained that the K-129 was struck by an American submarine, the USS Swordfish, which was operating in the Pacific at that time. They point to the fact that the Swordfish arrived at the U.S. naval base in Yokosuka, Japan, shortly after the K-129's disappearance, reportedly showing damage to its sail. American officials have consistently denied any collision, noting that the Swordfish's damage was the result of an ice incident in the Sea of Japan, unrelated to the K-129. Declassified documents show that the Swordfish was indeed operating far from the K-129's sinking location on March 8, 1968, making a collision physically impossible, based on the established timeline. More recently, some researchers have proposed a third possibility, that the K-129 might have been attempting to launch a nuclear missile in a rogue action by some members of its crew. Under this theory, the submarine was operating outside its patrol zone deliberately, positioning itself within range of Hawaii for an unauthorized missile launch when something went catastrophically wrong. This theory, while dramatic, lacks substantiating evidence and runs counter to the strict command and control protocols of the Soviet Navy. Most naval experts consider it highly implausible, though not impossible given the tensions of the era. What makes the K-129 case particularly intriguing is how it fits into the broader pattern of submarine incidents in early 1968. The K-129 disappeared on March 8th. The USS Scorpion, an American nuclear submarine, was lost on May 22nd, and as we've explored, the French submarine Minerve and Israeli submarine Dakar both vanished in January of the same year. 4 submarines from 4 different navies, all lost within months of each other. A coincidence so remarkable that it has fueled conspiracy theories for decades. A more prosaic explanation may lie in the state of submarine technology in the late 1960s. This was a period of rapid advancement in submarine capabilities without corresponding improvements in safety systems. Submarines were diving deeper, staying submerged longer, and undertaking more ambitious missions. But the engineering safeguards and fail-safe mechanisms had not kept pace with these operational demands. The partial recovery of the K-129 by the Americans represented a technical achievement of staggering proportions, regardless of its limited intelligence yield. The Glomar Explorer and its systems pushed the boundaries of deep ocean engineering and established capabilities that would influence underwater operations for decades to come. The ship itself would later be repurposed for actual deep-sea drilling, proving that its cover story had been technologically viable all along. For the families of the 98 Soviet submariners lost aboard the K-129, the truth about how their loved ones died remained elusive for decades. The Soviet government provided little information, maintaining that the submarine had been lost in an unspecified accident. It wasn't until after the fall of the Soviet Union that Russian families began to learn more details about the submarine's fate and the American recovery operation. In 1992, then CIA Director Robert Gates presented Russian President Boris Yeltsin with a video recording of the burial at sea conducted for the Soviet sailors whose remains had been recovered by the Glomar Explorer. This gesture, part of a brief post-Cold War thaw in US-Russian relations, provided some closure for families who had never known the final resting place of their loved ones. The K-129 incident underscores how underwater warfare during the Cold War created a shadowy battleground where traditional rules of engagement, transparency, and even international law operated differently than in conventional military confrontations. Submarines from both NATO and Warsaw Pact nations routinely conducted operations that, if discovered, could have escalated into direct conflict. The inherent secrecy of these underwater missions, combined with the technical challenges of operating in the deep ocean, created an environment where accidents could be misinterpreted as attacks, and where truth could remain elusive for decades. Today, the seafloor around the K-129's wreck site likely still holds pieces of the submarine, slowly being reclaimed by the ocean environment. The Glomar Explorer, after decades of service as a drilling vessel following its covert mission, was scrapped in 2015, taking with it many of the engineering innovations developed specifically for the K-129 recovery. The full story of the K-129, the Glomar Explorer, and Project Azorian may never be completely known. Significant portions of the operation remain classified even after more than 50 years. What we do know with certainty is that 98 Soviet submariners lost their lives in the cold depths of the Pacific, becoming casualties of a shadow war conducted far from public view, their submarine the object of one of the most extraordinary covert operations ever attempted. As with many Cold War mysteries, the K-129 incident reminds us that beneath the surface of official histories and public narratives lies a complex web of secrets, technical achievements, human tragedies, and geopolitical calculations, a hidden dimension of history that occasionally surfaces in fragments, challenging our understanding of events we thought we understood, and reminding us how much of the past remains concealed in classified archives or lost to the silent depths of the ocean. As we conclude our journey through the ocean's most dangerous mysteries, from the swirling enigma of the Devil's Sea to the Cold War intrigue surrounding the K-129, we're reminded that the world's oceans remain Earth's final frontier, a realm where ships and submarines can still vanish without trace, where natural phenomena can defy our understanding, and where the line between myth and reality often blurs in the endless blue horizon. The sea keeps her secrets well, revealing them only grudgingly, if at all. Yet our fascination with these maritime mysteries endures, drawing us back to the water's edge to gaze outward and wonder what other enigmas await discovery beneath the waves. In an age of satellite mapping and constant digital connectivity, the oceans still harbor darkness and uncertainty, reminding us that for all our technological advancement, nature maintains her capacity to awe, terrify, and mystify. Perhaps that's why these stories continue to captivate us. They speak to something primal in the human spirit, an acknowledgement that despite our centuries of seafaring and exploration, the ocean remains fundamentally untamed, unknowable in its totality, a world apart where the normal rules and certainties of land-dwelling existence no longer apply. As you contemplate these mysteries, remember that the same seas that have swallowed ships, concealed submarines, and generated inexplicable phenomena also connect us all, flowing uninterrupted around our single shared planet. The mysteries of the ocean are, in a profound sense, the mysteries of our world, enigmas that transcend national boundaries and speak to our common human experience of wonder, fear, and respect for forces greater than ourselves. Thank you for diving into these dangerous ocean mysteries with me. Until next time, keep your eyes on the horizon and remember that sometimes the most fascinating stories are those without endings, the questions without answers that continue to challenge our understanding and fuel our imagination. And before we part ways, I want to express my deepest gratitude to everyone who joined me on this extraordinary journey through the ocean's most captivating enigmas. If you enjoyed this exploration of maritime mysteries, please consider subscribing to our channel. Each subscription is like a lighthouse guiding us through YouTube's vast seas, helping our content reach fellow enthusiasts fascinated by the unknown. Hit that subscribe button now to ensure you never miss our future voyages into the unexplained, whether they take us beneath the waves, into the stars, or to other frontiers where science meets mystery. Until our next adventure, may your curiosity remain boundless and your thirst for discovery never be quenched. Safe travels, fellow explorers, and remember, the greatest mysteries often lie just beyond the horizon, waiting for the brave to seek them out.